Hello everyone, and Happy New Year. Welcome back for some more random ramblings and assorted game devings. Let's see if I can get my audio things in order. Do let me know if you can hear me all right and all of that. So everything seems to be in order here on my end, although the stream statistics window looks kind of funky and weird. Maybe it's a New Year's thing. I haven't been streaming for a while. Last time I streamed was 2025. Can you believe it? Hey, Bill. Language bike shedding, my favorite. Yes, today's gonna be language bike shedding to the max. So, let's do a little bit of an introduction round here, and background check what's been going on. I haven't been streaming since November. I have been busy with just all kinds of things. Some of them Madrigal, traction point related. Let's get the visual out of the way. Let's see if we can actually run the game here. So engine seems to be building. Game seems to be building as well. I think I saw you on the Odin Discord. I joined the Odin Discord a few days ago. Yeah. You might have seen me asking stupid questions in the beginner section there. Let's actually bring down the audio volume here in the master. Make it something like 30. Why's the music that loud still? There we go. So we have just a very slight amount of game audio here. Error loading mode Flying Scout, I think I know why that is. That is because we bumped the SDK version, yeah, and the mod is still on version 1. That's completely fine, we don't need to really think about that. I'm gonna update the Flying Scout mod at some point. Anyway, if you're new here, hello. I'm making this game, Traction Point, and I'm streaming a whole lot of the development of it. I haven't been streaming since mid-December, and the biggest reason for doing that is that I've just been sort of hunkering down, working on the campaign for this game. I need to make progress on that to be able to actually release this thing at some point. And to that end, I've just been working on it. But for the past almost 2 weeks, I've been actually working on at my other job, so I haven't really had any time to mess around with this game at all, really. Let's just boot into the demo mission here and make sure we can actually play this thing, because I haven't actually even been running this computer for some time. Let's make sure everything works here before we start messing with this stuff. And yeah, like Bill mentioned, I haven't been cited in the Odin Discord because I have this idea. I have this kind of strange idea, perhaps. For like a publicity stunt or whatever you want to call it, ad for the game, essentially. I mean, everything I do here on YouTube is like advertisement for the game, right? Let's be honest and clear about that. All of the streams that I do is essentially just like raising awareness and hopefully providing some interesting and entertaining content at the same time, right? But I had this idea, which I'm not gonna quite reveal what it is yet, because I don't know if it's gonna pan out. And And I don't really know when it is gonna pan out. But the gist of it is that I'm looking into other programming languages besides Zig and C++. So this game is written in Zig. However, it is running on top of a game engine written in C++. And yeah, now we shouldn't actually be able to spawn. Yeah, we don't have any flying scouts here because the mod doesn't load. Good evening, Victor, and welcome to the stream. You just started, so you're right on time. But yes, so that I don't make people nervous who actually want to play the game. No, I'm not rewriting anything in Odin or C3, but I'm looking kind of into how difficult would it be to have mods written in those languages for this thing. Just like very, very, very basic sort of fundamental support for those languages. Nothing special, because like in a way this tech stack is kind of special in the sense that it allows you to write mods for this thing in essentially any programming language, as long as you have some sort of ability to communicate over the C standard, C ABI, which essentially all programming languages do, right? And that is indeed how the game, which is written in Zig, communicates with the game engine, which is written in C++. And as of the last pre-alpha 3, we now have mod support. You can actually even make mods for this thing yourself. If you would like to kind of figure out how that works, you go to, let's see if I can find it here. Here we go. To this link here, which I will also paste in the chat for you. So this is the official way of making mods for the game. You write them in Zig, and there's a whole like set of instructions here for getting started. Here's the example mod, which is like a flying car, right? And yeah, so we already have support for you know, other languages than C++ communicating with this thing, and indeed the whole game is written in Zig essentially. But anyway, you don't really have to write your mods in Zig if you don't want to. You can write them in C++ or Rust or Odin or you know, whatever language can communicate with the C API that I have exposed, because it's just loading a DLL essentially and calling things on that DLL. And so this Odin thing came about because I was doing level design, or level, shall we say, white boxing for the level for the game, which I've been doing for the past almost a month. And I needed some kind of slight palate cleanser, because you know, you do something for a long time, you kind of get not bored, but you kind of get like a bit numb from that, right? So I was like, okay, let's look at Odin for a change, just as a something different. So this thing, which I'm sure many of you already know, and apparently Minebill is part of the Discord for it. I had never written any Odin like a couple of weeks ago or something like that, but almost a couple of weeks ago I started messing with this, and I found that it was actually kind of easy to get the very basics for this thing sort of running in the game. It was kind of easy and fast to write the necessary amount of code to have the game be able to load a mod written in Odin, right? That doesn't mean that the mod would do something like particularly useful yet, but you know, you could run it and you could see it here in the mod manager, and you could like print some things to the console whenever stuff happened in the game, things like that. I very much like Odin. That's cool. I haven't really been using it enough to form an opinion on it, right? And you'll see some of my Odin code in you know, in just a bit, and it's probably very non-idiomatic, and horrible as you know, Odin code goes. But yeah, I don't mind it. It's fine. It's actually kind of similar to Sig in many ways. And I'd be interested in seeing if this thing that I'm sort of planning pans out, Odin would definitely be part of that. I know I'm being a little mysterious here, but just bear with me. So, what I did a couple of weeks ago, and which I tried to improve later on, and that would have been the reason why Mindbill saw me in the Discord, because I was asking stupid questions, is that I let's see if I can find the folder here. I'm just gonna shut off the audio completely here from the game, because let's just do audio dot master volume 0. There we go. I have to live with both of them at the same time. Here we go. Right, here's my Odin. Here's my beautiful Odin code. I don't even have Odin on this machine, so the first thing that we're gonna have to do here is download Odin. Let's do that. How do I get Odin again? I think I got it from GitHub, right? This is how you install Odin. Yeah, here can. Oh, Gingerbill released a new version 3 hours ago. Let's see if it builds with that. There's Windows. Let's get the Windows version downloaded. And make sure we can actually run this thing. Yeah, this has not been written on this machine. Like I said, this machine has been probably like turned off since like mid-December. It's been like super cold over here in Finland. And so I haven't really been using this room I'm sitting in currently. And so yeah, this machine hasn't even been turned on. Let's see. Oh, that's not what I want to do. Here we go. Here's Odin, Windows AMD 64. Yeah, I think that's probably good. Let's get that and put it on the C drive. Here you can see my beautiful collection of Zig versions. So that I can sort of like jump back and forth between some of them if I need to. And we're gonna throw this in the path. So let's do environment variable. There we go. Environment variables. Let's put this in the path, so that we can actually use it from anywhere. New Odin. Okay. Now if we go here and we type Odin, we can see that yes, we have Odin installed. That's awesome, and version should now be the 2602. Coolio. Right, the next thing would probably be to install the Odin extension into here. And by the way, if at any point today you feel I'm doing something stupid, let me know. Let me go like, no, that's not how you do it. I saw the thing flash here on the screen. What happened to it? Odin. There's Odin language. There we go. This one. First thing I will say is that I feel the Odin language server is more stable than the SIGs. I'm sorry, ZLS people. I love you, but ZLS is pretty unstable. Are mods WASM? Mods can be WASM or they can be native. Ideally, they would be WASM, yes. So we can go here and see. We currently have here a setting in the mod manager, allow an unsandboxed mods. We're actually gonna probably have to set this to true today for the stuff that we do here on the stream. We can see here that this Flying Scout mod, which is currently not compatible with the game version. Maybe we should fix this as the very first thing. Actually, should be a pretty simple thing to do. Blah 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 blah. Yeah, the SDK version, as you can see here, is not correct, so it doesn't build currently. Maybe we can fix that. It is, however, a WASM mod. So yeah, you can make mods in WASM. WASM doesn't support, the WASM API doesn't support all of the same things that the native SDK does. So the Zig mod SDK, which is the kind of nicest of them all. Well, we have two now, essentially. We have the Zig SDK and then we have the Odin SDK, which has like 1% of the thing implemented, right? But the Zig SDK actually just gives you a compile error if you try to use an API which is not supported in WASM. So it just tells you like this is not available in WASM. Please bug me or build it as a native one, which would be a DLL. No comp time stuff to confuse the LSP. That might be one thing, yeah. That might be one thing. Like Zig is kind of tricky to parse, as far as I know. Like syntactically, it is pretty simple, as far as I know, because Zig has the interesting thing that, like, I think you should be able to parse. I can't repeat the thing now that they say, but it's something about, like, if you have a single line of Zig, you should be able to parse like the meaning of that line. That's why Zig doesn't have any multi-line comments, which is one of the more annoying parts of Zig, to be honest. You have to, like, multi-line comments would just be like a bunch of single-line comments. So syntactically, it's actually pretty simple to parse, but kind of like, you know, AST-wise, actually, like, parsing it is, like, lexing it is simple. Parsing it is tricky because of the comp time stuff. At least, kind of, that's sort of how I see it, right? Okay. Let's have a look here. If I can actually no, I'm not gonna mess with that other mod today. We're just gonna do this stuff that I was thinking we would do. That's not how you type it. You type app data % and then do trampoline. And we have the mods folder here. Yeah, you can see we have the first person camera is also disabled. You just put 2 underscores there. That's just my way of, like, marking it so that the game goes like, ah, okay, this thing is disabled, so we don't try to load it. And now if we look here in the mod manager log, we can see that it skips both the Flying Scout and the first person camera due to those underscores. But we do want the Odin mod to show up there. So let's see if we can actually build this thing. So it's here. Odin, source. Let's take that one and open this in VS Code. So open folder. Here we go. Yes, I trust the authors. I am the author. So trust myself very much. Hi, where have you been? Oh my god, my productivity level dropped without you. I'm sorry. I'm sorry, I promise to be better. Yeah, my January has been almost entirely spent doing level design. Just like hunker down level design stuff. And it's going pretty well, actually. So, yeah, I look forward to showing those levels off when they are a bit more actual levels and not just white box stuff. But yes, I will do more streams in the future. I very much look forward to it. This is kind of like a practice stream again to get into the habit of doing it. But welcome back. If this helps your productivity in any way, I'm happy to serve. Okay. All right. Here in all of its beauty is my main Odin thingy. You can see some of the like commented out test stuff that I've done here. Maybe we can even just like we can just take all of that away. So we have this thing here. So how would you set up a component in Odin so that it could actually be used in the game? Well, if we look at let's put this on this side, and then we put where's the other one? Why are you not showing me the other window? Oh, it like dropped it completely. Let's do a new window and put it here. So we can do something like I don't know which of the components would be the simplest one. Game object component right here. I probably need to like sort this by size or something. Sort it by size. Game unit component is apparently very small. Well, here we go. Hey Shugrado, welcome to the stream. So here we can see sort of like the two sides of the same coin. These are actually kind of similar now that I look at them. And those guys would go away, but maybe we can actually bring them back. So in Zig you have a struct called a game unit component. Structs in Zig can have functions, member functions, methods essentially, even though Zig doesn't really call them methods. But anyway, you can have a create, destroy on object created, and you can have like update functions and all of that good stuff. In Odin you don't really have that. Instead you have just a component which has some data fields, and then you have loose functions that you can use to or procedures, I should say. Some loose procedures that actually like pokes at the stuff. And the way that I currently do this, which is sort of like something I would like to get away from actually, is by using function pointers. So you just create like a component function list here. You give it the type of component that you're actually thinking of registering, and then you assign this test component create here to the create field. If you don't want one of these, you can just take it away like this, and then you take it away from here as well. And now the thing just doesn't have a create function. So it's a little bit like wrapping the game engine's somewhat object-oriented API around like a language that doesn't do object orientation, right? I'm hoping that makes sense. So all of these components, or all of these procedures, are essentially like the functions of this guy, a test component. So when the thing is created, it creates test component, it prints test component create and sets, some field to something. When we destroy it, it prints that, and when the object has been created, so when all of its components have been created, we print this, and then we actually print the field to make sure we actually can can like see it being set and all of that. So that's pretty cool. Essentially all of this boils down to this thing, right? To the outside world, we essentially only need this register function, because this register function collects all of these functions together into a function list, and then it calls init component type, and it gives the actual like type that we want to use here. We give it the Odin.test component, is like the name of the thing. That's basically like this thing here. Could maybe increase the font size. Yeah, sure. Let's do that. Something like this, maybe. And same thing here. I hope that's better. So here on the Zig side, we have a bunch of fields. We have a registration name. This is what the data will use when it will, you want to create a game unit component. You need to use this registration name here to tell the game engine, hey, we want actually one of these game unit components. Use this means.gameUnit component. Also have an update order, so sort of like how, if you want this component to be updated, which we actually don't want here because we don't have an update function, so this essentially doesn't do anything. But in the frame, how soon do you want this thing to be updated? So it goes from 0 to 255, if I remember correctly, 50 being the default one. And then you have a context. This context here is very different to something like the Odin context. Context is essentially like the base class for a game object component. But since we're not working with object-oriented languages here, we don't have base classes. But this can be a game object component, or it can be an avatar tracking component if it's actually like part of an object that you want to read input and things like that. You can see basically the exact same things here on the Odin side. Here's the type. So the first parameter, parameter of this thing would be, let's see, can I get the auto completion here working? Terminal. Let's see, we have the LSP running here. Odin language client. I don't know if I have that. Kinda looks like I don't. Let's maybe restart that thing. And maybe do a new window here. Can we get the LSP doing things? New version of OLS is available. Requires reload. Okay, let's update that and see if it actually kicks off. Odin cannot be found in your path environment. Well, that's stupid. We do have Odin here. Odin is a tool for managing Odin source code. Let's maybe like shut this down completely, all of the windows. Maybe it requires like a full thing, a full reboot, or whatever, to actually work. Let's see. If you type basis, yeah, now we go. Okay, so now we can see all of these things. Good, excellent. Right, so this thing, init component type. You can see the first parameter there. I can actually move the mouse here. Here's the type ID. So this would give it the test component type. We give the component type name. That's the same as this registration name here, right? And then we do the component context type name, so that matches like this line here. Then the function list is of course like this list of these functions that we have down here. And we have the update order that maps to this guy here. And then we have a callback, which is just this thing that comes in here that actually like goes and registers this type with the game engine. Finally, Odin enjoyer. maybe. I haven't decided yet. Yeah, I was just saying before you joined that like I've only been doing Odin for like a week and a half or maybe 2 weeks. So I haven't made up my mind yet, but yeah, it's not bad. It's not bad. You need an OLS JSON file. I think it created one for me. Yeah, here we go. Here's my OLS JSON, which I haven't touched at all. I assume it's probably good. I use the Odin create project, whatever it's called, like init project thingy, to get this going. So anyway, here's my test component. So far it doesn't do anything particularly interesting, but you can see that we have like the whole lifetime of the component is already here. So we create it, we destroy it. We get notified when the object is created, and then when the thing is updated, pre-ticked and ticked. So update is essentially like every frame, if you want that, and pre-tick and tick are the fixed rate updates, either before physics is stepped and after physics is stepped. So depending on if you want to like give impulses that you want the physics step to take into account, you typically do that in pre-tick. And in tick, the physics has been stepped, so you can react to it. And we have the exact same thing here. So like, for example, we can do pre-tick self, and we need to give it tick delta time, just like we do in Odin, and this actually needs to be like an error returning thing, like this. And this will now get automatically called on the Zig side, thanks to some comp time magic that happens here. We're not using function pointers or anything like that. It is actually like a fully normal function call. Here we are currently doing function pointers. These are all function pointers in this component function list you can see here. So I'd like to get rid of this. This is what I was trying to do the other day on the Discord. Couldn't quite get it to work yet, but we'll see. We'll see what happens. That's like not a knock on Odin at all. It's just like me not really knowing what I do yet at this point. Anyway, can we build this thing? That would be the interesting thing now to see. So I think I had a few batch files here. We have build debug, and we have build. So let's do build debug. I think that's probably the more interesting one here. And there we go. We have a DLL. Yay! Here's our DLL. See, I just threw this in SVN next to the rest of the data actually, but yeah, 1849, that would be right now. So the thing actually builds on this machine. That's cool. If we take that away and run it again, we should see it pop back up. Cool. This is now actually like a mod that we can load into the game. If we run command, can you please run command? Thank you. Oh, we actually need to probably be in the Visual Studio command, developer command, shell or prompt. So if we do dump bin exports, I think it is. We don't need actually that. We just need the Odin DLL. Oh, never mind. We need to go in here first, and then we can do dump bin exports Odin mod.dll. You can see it exports a whole bunch of things. Are exported from this guy. Hey Tutu, welcome back. No, you're right on time. I'm just rambling here. Yeah, these are essentially all of the things that the game engine requires at a minimum that you expose from your mod DLL. These are all of the functions that the core game engine expects you to have. So exported functions, essentially. If we go have a look here at the main Odin file, you can see some of these guys. So exported procedures. I need to use the correct terms here. When we are in Odin land, we're talking about procedures. I'm probably gonna say functions because that's what they've always been called in my world. But anyway, we have these exported procedures, init library, for example. We can find that somewhere here in the list. Here's init library. This guy, get version number, that's another one that we could see here. That's that one. So if you load a DLL into the game engine, it expects to find a whole bunch of these functions, and it can then call them at the appropriate times. And if you use some of my other middleware, such as like the Timbre audio engine or the Merlin particle systems, things like that, you need to expose like a whole bunch more actually, so that it can hook those up. But we don't do that currently. You can see here, 0 means no basis init flags. To have the engine bind middleware, we need to specify their binding flags here. See the SIG code for how to do that. So the SIG SDK currently does a whole lot more. Like here, for example, we bind Goofy, which is the UI library, sound library, mission scripting, particles, and then some like auxiliary things. And then we use these flags here, and we actually just like hard-codedly bind all of them right now, but you could basically turn them on and off. But anyway, we don't do any of that here, so we have only a subset of things, meaning we can't, for example, currently play any sound from this mod because we don't have that thing exposed to us. But we can do all of the basic core game engine things. So we can like, we can have meshes in the scene, we can have physics objects, we can send and receive messages, all of that. And so that's pretty cool. Now, what happens if we actually just drop this thing into the mods folder? So let's create a folder here. We're gonna need a JSON file for that. Let's create a folder here called Odin mod, and just copy this guy here, and we'll just call this Odin mod. Odin mod. I don't know, Odin test mod, something like that. This is just something that the game mod manager requires us to have. And then we can actually just drop that thing in. We can maybe even take the PDB file here if we need to debug it. And let's see what happens if we run the game. So go over to this side, press F5. And here we go. So, mod manager has Odin mod. Oh, it's not allowed. And that is exactly the thing that we talked about earlier. This is a native, unsandboxed library, a DLL basically. So we need to just like allow this thing to actually run. So now it is allowed. You have made changes, restart the game to apply them. Yeah, but we also should enable the mod. So now restart to load. Let's just do that. Just shut this down. And we will run it again. Alrighty then. So, hey, now we have our Odin mod loaded. So the Odin mod doesn't really do anything yet. We're not even creating a mod controller, which is like something that you might want to have if you need like more complicated things, like loading resources at startup, stuff like that. We don't do any of that. The only thing we do is we expose a component. So we can see here, native app loaded 57 Zig components. That's the game DLL, which is like brought in through the same system. Then we have here native mod loaded 1 Zig components. Well, what this thing actually doesn't know is that this isn't the Zig components, it's an Odin component. But the output here is just like hard-codedly claiming it to be a Zig component, because that's the only thing that I've supported so far. But that's actually an Odin component. And that Odin component is available to us on this name here. So that's pretty cool. Maybe we can do something just to test this out. don't think I've actually done this, but like we should be able to just print things here already. So if you do like print F. Hello. Hello. Or hello, as all of the Odin tutorials say. This is Odin. This is Odin speaking. Something like that, right? And then we do rebuild it. I like the fact that this builds so quickly, but it might also just be that these libraries that I've had so far are kind of small. But the Odin compiler seems to be fairly fast. So now we should be able to see the thing here. Yeah, look at that. Here's our output. Right before the game decided that, oh, okay, we actually loaded one Odin component. See that the thing is actually running now, so that's pretty cool. And we can even use this component. It doesn't do a whole lot. It just prints some stuff to the output. Let's see. How do you handle module virtualization? As I saw, you have native and not native libraries. How do you run non-native libraries? Use Lua WASM runtimes for safety. Yeah, that's the idea. You can actually see sort of a hint of that. Oh, I can't run it from over there. Yeah, sorry, Odin. Let's run it from over here instead. If we go here and have a look at the output, still you can see WebAssembly micro runtime WAMR version 243. So that is the WebAssembly runtime that I'm using. WAMR. This guy. I'm sure there are others. WebAssembly seems to be a very kind of like Rust-friendly environment. So if you happen to be writing in Rust, which I'm like generally way too stupid to do, but if you are, then I suspect there are easier, more sort of like mainstream runtimes or something like, you know, we have like WASMR. WASMR I think is one such thing, or lightweight containers. Okay, maybe that's not it. It's like WASM run. What's it called? No, wasm time is actually what I'm thinking of. This thing. Yeah, this is written in Rust, and I guess I could technically probably use that from C as well. But yeah, this the WAMR runtime is written in C, and so it fits right into my C++ engine code base. But yeah, this is how I run them. There are some additional hoops that you have to kind of jump through to get the interfaces to kind of hook up correctly. Oh yeah, I can show you that as well if you want. Let me know in the chat if you want to see that sort of thing. It's not really like on today's agenda, but sure, if you want to, I can show you that. But that's like a separate thing. I can quickly show you here, at least on the Zig side, where like WASM is actually a thing, because some of these functions here are sort of duplicated. There's a basis init, but there's also a basis init for WASM specifically. I think I needed to pass some of these parameters kind of slightly differently. So this basis init underscore WASM then like ends up calling basis init, the normal one, and then like returning the flags, blah blah blah. But yeah. Anyway, let's see if we can actually have this test component like in game and do something. Just printing these things so we can see that this actually works. Even on the new Odin version, which was released 3 hours ago. And I choose to believe that Ginger Bill released it for me specifically for this stream, right? That has to be the case. So how do we do that? Well, we basically tell a game object to create one of these Odin.test components, right? So I think like one of the easier ones, one of the easier object types that we can do that on is probably like one of the pieces of cargo. So if we have like dynamic props, like here, like we have a box like this, or a box like this. Some of these things are kind of easy to spawn into a level, so maybe we'll use one of these guys. Let's create it. Let's put it on this guy. So I'm gonna copy the name Odin.test component, like so. I'm gonna put it here. Odin.test component. Odin test comp, whatever. And it complains that it doesn't know what that is because we haven't registered it with the UI or anything like that. It's fine. It's fine. Trust me, bro. It is there. And now we don't get any UI definition because we don't have anything set up. And for that matter, we don't have any support for like having properties in the code anyway, so it doesn't really matter. Yeah, I can unload that because we don't have any visual representation of anything for this component. Then we can create it on the client or the server or both. I think we're just going to create it on the client for now, so we get like one output, right? Otherwise we get like both of them. So if we create one, we get like two of these create component calls. And that should be it. That's all we need to do. Did I save this? I think I did, but let's save it one more time and let's go into the game. Let's go into where do we want to go? Maybe depot is fine. Good old depot. Okay, here we can see actually already test component create some field 1, 2, 3. That should look familiar. We're setting some field here to 1, 2, 3, and then we're actually writing it in the onObject created call. So when all of the components of this guy has been created, we actually print that out. We can even print some more here. Let's take the output and not block it. I can plonk down a few more of these. Here we can see. Hey, and if we go and delete this guy, I keep blocking that by highlighting things here. We get the destroy. So that's cool. Now this of course isn't really new. This has worked for about a week or something. I've been doing this in like my off hours. But yeah, I haven't done it on this machine, and I haven't done it with this version of the Odin compiler. So that's cool. That means that if we want to make Odin mods now, we essentially just have to expose more of the API to the Odin code. Make some sort of like small standard library or whatever, so that we can actually like talk with the game engine in Odin. That shouldn't be very tricky to do. Let's see if we can find some more of those boxes. I think they're all here. Yeah, here's some behind the house. Behind the highly unfinished house, we have a few more of these guys. So if we destroy one of these, we also get the test component destroy. So that's that. That's kind of like the Odin part of this thing. You might be wondering, okay, how did I actually expose all of these things to the mod if I wrote just a very small piece of Odin code to make this happen? Well, the same way I did with Zig, by quite simply generating that stuff. So I have this thing called SirBindALot, which is a binding generator, which I use to bind essentially like C++ types to Zig. And I just went in and created an Odin writer for that. So that's literally like one C# file, and it creates all of this stuff for me. And this is what actually creates these exported functions. You can see bind core, bind app, bind mod controller, all of the exposed types, client, server. All of this stuff is generated, and then we also have the sort of types or like type definitions or whatever that gives us slightly easier to work with names here. So when we show an assert dialog, we have essentially a function with this signature on the engine side. We want to call that somehow. We have a type def. It looks like this. Core show assert dialog. CB stands for callback. We need to store it somewhere, so we store it here as the very first one. And then we have this bind core, which actually like receives that thing and stores it in the place. So if we want to show an assert dialog now, we can quite simply just call this thing. Let's actually try that. Let's see if that works. I don't have anything to assert on, of course, but let's make it happen. What does that actually look like? Let's copy this guy. Yoink. And yeah, whenever we destroy one of these guys, let's assert something bogus. Some bogus stuff. Does Basis have a classical OOP architecture as Unity, Unreal, or entities and components stored in some fancy ECS table-like structure? It's closer to the classical OO style. Yeah, it is not really. It's not really like Unreal, and it's also not really like Unity mono behavior. But I guess it's in some way it's kind of similar to Unity mono behaviors. I'm gonna show you. Your ability to yap about tech things is remarkable. Thank you. That's beautifully put. I'm gonna show you one of the C++ components, because all of these like additional layers, Zig and whatnot, kind of boils down to like, what does the engine actually think is a game object and a game object component. So we have, let's say the mesh component is a very, very sort of central. Let's make that a little larger. I'm gonna actually just close all of that down. Yeah, here is like the actual components of the engine. Mesh component derives from game object component. This is where all of the game object components derive from. So you could sort of like think about this as the mono behavior. There are some more special types on top of this that you can use, like transform component, avatar tracking component, things like that. C++ gives you a bit more flexibility and power than Zig does currently with this thing, just because of the fact that you can just directly derive from whatever you want. But yeah, so this looks, kind of similar to what a mono behavior style component does in Unity. Then I have this additional layer on top of this called the game object type, which is essentially like what we're looking at here. We have these things called blueprints, not to be confused with Unreal blueprints, have nothing to do with them. These are essentially just like pre-packaged lists of components, kind of like prefabs in Unity, except this is the only way that we spawn objects in Basis. And some of these things are actually like super flexible, like the quick mesh type used for the Blender sync system. You know, all of them are just coming from a single game object type, but they can obviously like look very different and all of that. But yeah, it's not an easy yes. I do have a video on the channel where I actually plug an ECS on top of this thing, which is something you can do. You don't have to like have either or. The game engine's model is definitely more of an OO thing, but you can absolutely have just, you know, you can have like a single game object in your game, and inside of that game object you have an ECS, and then you just create entities inside that ECS. That's completely fine, and that's even supported by the game engine. So if you really want to work with ECS, what I did was I basically plugged this thing, entity, I don't know exactly how you're supposed to pronounce this thing, but I plugged this into the engine and made some like adapter components, so that like when you create entities inside of this registry here, it actually went and auto created and destroyed some game objects based on that. But you don't even have to do that. You can just work entirely with entities if you want to, and even just drive the graphics engine from that, so that, you know, all of your entities have their own meshes and everything. Because that is essentially exactly what this mesh thing does, for example, here, right? We have create mesh instance here. This thing just goes in and like creates a mesh instance in the render scene, and then sets some flags on it, and like visibility and blah blah. So you can just use the graphics engine is essentially like completely separate from the object model. I hope that answers your question. Let's get that out of the way, and let's try this assert thingy that I was thinking about doing. I think this is the last thing we're gonna do with Odin today, because I want to get to C3. C3 is like a completely new thing for me. I only found it like yesterday, and I was like, hey, what's this thing? It looks cool. So I figured I'm gonna want to try to actually do the same thing with that. Right, so we are now in the, what is this? There's the package called Odin mod, and we want to show an assert dialog. So we need to do basis Odin. This is this looks a little stupid, these names, but that's because these are auto generated. So we have some like duplicate things here in the name. C3 is cool. I think so too. I think it looks really cool, and I wanna try it out. Okay, here's one thing that I feel Odin is a little wonky with. I'm sorry, all Odin fans. This is just like, it doesn't make sense to me. Show assert dialog. Let's have a look at what that actually looks like on the C++ side. Show. Oh, I need to find it. Show assert dialog. And we need to find it in the Zig bindings specifically. Like everything here in the C++ code actually refers to Zig. You don't really need to think about it as Zig. It should probably be called something like FFI, for foreign function interface or something like that. But like the game thinks everything is Zig. All of the DLLs are Zig DLLs, even though we're actually loading an Odin DLL here. But this is the prototype for this show assert dialog thingy. So it looks like this. Like these are const interrupt string pointers. As far as I know, this is how you're supposed to like pass a const interrupt pointer. So by point, like hashtag by pointer, and then not have the pointer sign here, rather than doing it like this. It's very strange. I don't quite understand why they do it like this. Like if this wasn't const, as far as I know, you should pass it like this: message and then pointer to an interrupt string. But since they are const, I think I read the documentation that they should be like by pointer. Odin doesn't have a notion of const, so byref was added for bindings. Yeah. Since we're talking about like a C interop layer here, I think we could probably just use this thing instead. And you know, neither C++ nor Odin would be any wiser. It would probably just work. But oh well. It is what it is. Let's do the correct Odin thing here and use by pointer. Another thing is that interrupt string. Can I go there? Can I interrupt? Oh, it's actually basis interrupt string. That's why it doesn't give it interrupt string. This is essentially a slice, right? It's a pointer and a length. So I don't think we save a whole lot by just giving this as a pointer. We could just give it by value, and it would probably be just as fine. But that's not really like an Odin thing here. It's just like my API is a little strange. Anyway, so this thing wants two interrupt strings. Let's create them. Let's call the first one message. I do like this. I don't know what this is called, but like declaration and assignment all in one. I do like that syntax. That's kind of neat. And I had two interrupt string, and then we can give it just like a normal Odin string here. So hello, fancy assert failure you got there. Something, I don't know. And then title TTL. Oh, caption actually, cap. Something assert failed. Like so. I don't quite like the fact that like, you know, you shouldn't put semicolons at the end of things. I've come to believe that, or I've come to understand that it's not idiomatic if you have them there. It does allow you to have them, but it's just strange. Like either don't allow them or require them. Don't like, you know, have both of them, both of the options. Right, what is this actually complaining about? Too many arguments. Oh, what? MSG? CAP? Why is that too many arguments? Isn't that exactly what we want here? Like there's a return value, which is like, probably need to do that. Yeah, that's strange. Too many arguments. Who cares? Well, I care. You're not calling a function, am I not? Oh, that's right. Yeah, it needs to be app. Yeah, thank you, Bill. The thing I want to call is actually looks like this. It's basis underscore core show assert dialog MSG CAP. Yeah, exactly. Here we can see the difference. That is a function pointer, and that is a type alias or whatever. Yeah, that's what it's called. Yeah, I do care. Just like I care that like JavaScript can have them and or not have them. I think it's like super. It makes the coding style very inconsistent. I don't know. Maybe it's just me, but it like it annoys me. All right. So. We're calling this now in the destroy function. So if we destroy one of those boxes, we can go into that same level, depot. If we destroy one of those boxes, we should get an assert failure. And it's actually like it's an assert failure without asserting anything. We're essentially just calling the show. Hey, look at this. And now we can like, let's not exit here. Let's just ignore. But I think the ignoring, yeah, it will. Even though we're ignoring this particular assert, the ignore doesn't do anything because like we haven't hooked up the proper, so sort of like don't care about this thing anymore. But you can see that we can actually call like core engine things like this. And so, you know, if we look at this in Zig, we have it here. In this kind of we have some WASM business here. I actually want to search for that assert, and it's probably actually this one. Yes, we check the expression, and then like we do some string formatting here. We eventually do the same thing. We do the core show assert dialog thing here. And then we handle some of those. I don't think we handle the ignore here actually either. Ironically enough. But yeah, we do a breakpoint if we click break there. So that would be that. That means that we can actually like communicate with the engine kind of nicely now. And we actually have all of those function pointers set up for us already, right? They're all here, all in this one big file, all 918 lines with some empty lines of things that we can call. We have some IM-GUI stuff here, streaming, level data blocks, game state, game session. All of this is already available to us in Odin, and I think that's pretty cool. Renderer, resource, vehicle controllers, characters, physics joints, actors, shapes, scenes, all of this stuff. Even before we've actually even really done any Odin coding, we have all of that functionality available to us, and that's really nice. That's neat with these like new systems programming languages, is that interacting with like C over a C API is so easy. That it's really quite simple to set this up. So let's look at what that code actually looks like, because it's remarkably simple as well. The code that actually generates that Odin code. And it's called Odin Writer, yes. So this is just copy pasted from Zig. So there's some Zig stuff in here that I just haven't bothered to take out. Like we don't really need any imports for Odin, so I just return an empty string there. This is what we do for Zig. Then we have a table for converting of the C types into Odin types. So here for example we have this const bool pointer becomes like a hashtag by pointer boolean, right? It's just one big table of stuff, and then we have write generated types, write bind functions, and write function pointers. Some very fugly C# code. We might actually get to doing this same thing for C3 tonight. So we generate this file, this file, and this file. And you can see they all begin with this file was generated comment here. And then we just run it on the same input. And ideally, we get a bunch of bind functions that look something like this. And that allows us to run the dump bin and get all of this stuff. And then we can just load it into the game. It's almost like... It's almost easy enough that you can like introduce a new programming language that can be used to create mods in like an afternoon. And I want to try to leverage that for some fun stuff. Some stuff that like really shouldn't take very long to do, because I don't really have time to do anything fancy and long. But I can do some fun little things. All right, I'm gonna go get a little bit of water, and then we can turn our attention to C3. Alrighty then. So, let's put Odin away for a little bit. How many of these browser thingies did I have open? What's that? Oh, that's a group. Okay. Yeah. Okay, yeah, okay. Windows is just confusing me. That's fine. So, C3 language. This is something that's quite new to me. I think I might have seen something about this, like on YouTube or something. But this looks kind of interesting. Immediately something is bothering me. We have this like FN and then void. I'd like the void to be here on the other side of the name. This looks a little strange. And apparently this FN is added here for ease of parsing. So things like tools could parse this thing easier, because like it's as everyone knows, like parsing C and C++ is super tricky, because you don't know, is this like a is this a function prototype? Is this a like some sort of function pointer or function like forward declaration, whatever. And this just makes it less ambiguous. But this thing is kind of like C, but it introduces some things that like I really like and would like to see in a modern language that I want to use for all kinds of things. This is not garbage collected, first of all. It is just a kind of like on the same level as SIG or Odin in that sense. Minimal runtime. It has a module system. Super nice. I kind of happen to like headers, actually. I like them in the sense that they present you with like the interface of whatever you're looking at. But I don't like them in the sense that they just tend to introduce a whole bunch of issues if you have like a really large code base and you want to make some changes, and you just have to like recompile the whole thing quite often. That sort of thing. Not to mention all kinds of like circular dependency things that crop up in like large C++ code bases and whatnot. So I like a module system. And no, C++ as module system is not... I'm super skeptical about that. It kind of doesn't work. And it's kind of like too late for that to ever properly take off. Especially if you're not in control of your entire code base. If you have some third-party code libraries, whatever. No one uses it. No like third-party code providers use it realistically, and that just causes all kinds of issues if you try to use it. So, in my book, the ship has sort of sailed on that. I might be wrong, and that would be nice, but I don't think I am. C3, however, is not backwards compatible. This is a new language. It's an evolution, not a revolution. But it's still, this is a new language on like compared to C or C++. So they can go with modules from the very beginning, and the little I've actually looked at this, it looks pretty nice. So I'm hoping it is. What else do we want to like? None of these like necessarily are like super important to me. Like this is nice. Operator overloading is definitely nice to have. It's something that I wish that Zig had. Because writing math-heavy code for games can be kind of nasty if you have your own math types. So that's really nice. This also has some things that I wish Zig had. Let's go and have a look here, for example. We do have interfaces. Actually, I think I can find it here. Yeah, here we go. So we do have interfaces. Like here, interface and functions. And then you kind of, that's the name of the thing. And here's a struct, and you kind of specify that the struct implements the interface. You also have, of course, methods. They're sort of like declared outside of the struct. That's fine. It doesn't really bother me all that much. But I'm kind of thinking this might actually fit better onto basis than Odin does. Because we already have these kind of like OO-ish things here. And I know they're not really in vogue these days. But it happens to be kind of like the base we're sitting on. So maybe the next engine will be very ECS oriented, I don't know. But this should be kind of nice when you're trying to actually use the game engine that we have. What else? This had some other pretty cool things. Like these macros look kind of interesting. They're sort of like, kind of looks like they are like a slightly more sane version of like the preprocessor. You can like do some code generation here with this like macro syntax. I had some kind of interesting examples that I looked at, but I'm not sure if they were here or not. Might have been some YouTube video I saw. But yeah, this looks cool. This looks cool. We have slices. Where's slices? Slices. Here we go. So that's probably like one of the like really big improvements already over C. Is that we have slices, which just like makes, you know, array or list handling overall a lot easier. What else? We have like proper strings. Memory handling is, like I said, is manual, but this thing has some kind of interesting abstractions here that C doesn't even have, like temporary allocations. Like you can set up pools like this. And if you use a temporary allocator and you have a pool, the pool is automatically deallocated when you exit the pool. That's kind of interesting. One thing I didn't like about C3 was the weird way they did generic up until a while ago. Yeah, okay, so you're talking about, if I, or correct me if I'm wrong, there's a note here that up until the version before 0.79, they only had module generics. Right? So you do like your generic type here on the module, and then you can use that type within your module. As far as I know, that was the only way, or like if I understand this correctly, that was the only way you could do generics until this version. And now you can do generics directly on structs. So I'm thinking that is probably kind of nice. I'm not sure. Can you actually use? Can you use the type? Can you use this type, this generic parameter, in methods if you don't have them on the module? Like, is it required that you have a module level generic parameter if you want to use those in? Maybe we can try that out actually. Let's try that out and see what happens. Yeah, you can even group these like based on. I think that's one module, yeah, and then you have another module here. So you can have like multiple modules in one file. That looks kind of messy. I don't know why I would want that, but maybe that can be useful. I don't know. Yeah, then there are some of these things that look kind of like this is some sort of, what's that, like concept or contract or whatever it's called. I don't know a whole lot of these terms and what they exactly mean, but it looks cool. It looks like a cool language. It has certain features that I wish Zig had. Let's see. 25th for 20 says, I remember joining the server to talk to you with talk about you with Ada and Odin. Do you prefer C3 or Odin more? I say C3 slightly, but I do like Odin's opinions. So, I wrote my first Odin line of code about, let's say, 2 weeks ago. That was the first time I ever wrote any Odin, and I have never written any C3. I've never written a line of C3. So I can't really give you any opinion on either of them yet. I'm hoping to write my first C3 here in like 5 minutes. Also, yeah, the requires clause is a contract, so it's like an assert. Yes, contract is what's the term I was looking for. Yeah. Yeah, this thing has just like a whole lot of really neat ideas. I don't know exactly if they will pan out or not. Oh, this was interesting actually. Yeah, with the any type. So the any type is like is a pointer and a type ID. So you can like do switches based on the type. This is kind of an interesting way of handling like runtime dynamic casting, perhaps even dynamic dispatch if you want to sort of like hook it up to one of these switch cases. It's neat. It's neat, and I think like compared to Zig, based on what I've seen here, is like two things that kind of bother me with Zig a little bit is that they don't have interfaces, and they don't have operator overloading. Remains to be seen how well these work in C3. Like I said, I haven't written anything yet, but yeah, this looks nice. This looks nice. Kind of look forward to trying this out. And yeah, don't worry. Traction point is not going to be rewritten in Z3. But I found this and I was like, hey, yeah. This is cool. So let's see. We're gonna have to use some generics to set up the component framework, if you will. So the way we do it here in Odin is we have an exported function called register component types. This is where the game engine expects us to register our types. or component type. So for each component type that we have, it wants us to call this callback. The callback has a bunch of things that we want, that it wants us to fill in for that. This is one of the first things that we need to implement here if we want to actually use this for mods. And so what this thing actually does is that it goes in and creates a so-called component factory, which looks or sounds a little Java-ish, perhaps, but it's actually not. It's a really handy sort of indirection between just the game object world and the individual components, that you have like something that creates them and manages them. And we do that using a generic type. So we have a component factory of a certain type, right? Now this thing just has a dynamic list of type pointers, because this was the easiest way to just get it running. But like this could, in theory, this could like allocate these components in large chunks. So not through any pointers, just like essentially arrays where you have the memory kind of laid out nicely in a cache efficient way. And yeah, this struct is templated here on this. This is called parapoly in Odin. It's like, what is it, parametric polymorphism or something like that. So we're gonna have to do something kind of similar in C3 if we want to make this work. In Zig, this looks actually kind of different, and I do like the way that Zig does these things. Here, of course, we use the compile time code generation. So let's see, init component type. I think it goes through and creates a factory here. Yeah, here's the thing. So this is the function that takes in a type and it returns a new type. So that's why this the return value is a type of this. And here we can do a whole bunch of things like at compile time. This is what I like about Zig a whole lot. And I kind of wish that Odin had this. It doesn't, but it has some other things to like work around these things. But this is very, very nice in Zig, that you can just like immediately go and ask the thing, hey, does the type have an update method, for example, or declaration to be exact, but like a method is what we're kind of expecting this to be. And then based on this has update value, we can like leave out code completely if we don't want that. It's all done at compile time. So we do kind of the same thing here in Zig, in that we have a game object component factory that is templated or generic on a type. It's the same thing we have here, and we're gonna have to do something similar in C3. So that's why I've looked into the generics a little bit, but it should be fine. I think it should be fine. Okay, let's see. To be fair, I like POD structs, but if I do a couple interfaces, if I know my data type should be ADT-like. A doubly linked list with an interface is a good toy example. Why do you want it to be a linked list? I'm trying to like to parse what you're saying here. Why do you want it to be a linked list with an interface? What does the linked list help here? Maybe I'm just being slow. Maybe it does. I'm not sure. Anyway, that was just a kind of a tangent of why we actually need a little bit of compile time evaluation, and why we need generics. Not sure this this compile time stuff is something I can actually use for that or not. But maybe. It would be nice. The nice thing about the Zig compile time evaluation thingy is that it can do essentially everything. By you just give it a type, and it kicks off the entire thing. It generates the factory for you. It hooks up all of the compile time flags, and it packages it in a way that it can be like easily sent back to the C++ side, all from a single call. And in fact, I don't actually even call anything. I just put it into a list, just here. So here we have a list of all the components. So the only thing I need to do to register a new component on the Zig side is add that component type to this list. And you can see here the CLS is trying to show us what it is. It's like type. And then we have a compile time, like an inline 4 or comp time 4, which iterates over all of these and generates all of the factories and everything for it. Let's see. ADT abstract data type. Yes, I've heard that term. Judith as a toy example. That one I don't know. If you had the list as a struct plus give it an interface to append and remove elements. Ah, okay. That's preference. Yeah, I don't typically use linked lists for that much. I guess I've been kind of burned by the cache incoherence of it all, or something. The way I do it here in Zig, which I think is a pretty nice compromise, is that I have an interface to the factory. I don't have an interface. Well, I have an interface, but it's not like there's no vtable or anything like that to the actual components. So if you go have a look here at the factory, you can see here at the very top, here is a polymorphic interface for component factories, and we have a virtual table here, a virtual function table, whatever, vtable. You can see all of the function pointers that we need the factory to essentially to support. And the reason we have the factory here is that the Zig library has a list of these factories, and they all need to have the same interface, so that the C++ side, through the C interface, they can interact with all of them through, and they all look the same, right? So if you have like an update, for example, you call update on the factory using a function pointer like this. What you don't want to do is you don't want to call update on each and every component instance using a function pointer, because then if you have, you know, let's say you have two different types of objects in your level. One is a dynamic object like a box, and another one is a car that you can drive around. And you need to update them both. That would mean that you have two functions, two factories, so two calls to a function pointer per frame. But what if you have 2,000 of those boxes and 20 of those cars? That would mean that you have 2020 calls through a function pointer, and that can get kind of slow. So instead, I have the function pointer call to the factory, and then the factory has the factory knows how to call the update function of the component directly. So, you know, if you have something like a driving component, probably has an update, for example. Actually, it doesn't, but it has a pre-tick and a tick, I'm sure as well. Yeah. So this thing is not called through a function pointer. It is just a normal call to a function, which we know already at compile time where that is. And that's very nice, because then if you have 2,000 boxes and 20 cars, you only have 2 function pointer calls, and the rest of them are just normal calls per frame. And you can do that because of things like this, where you have just to pre-tick, find the thing where it actually calls it. Here. This thing is called through a function pointer, but once we've done, let's not break it. Once we've gotten here, we can do the for loop and then just call the component directly. This is not a function pointer call. This pre-tick here. That's kind of what I'm trying to do. I don't have this working yet with Odin. With Odin, all of the calls are function pointer calls currently, unfortunately. So in Odin, we have a component factory interface, same as before, except I don't have all of it done yet. But I have an update function pointer here, and if we look at what that looks like, we have the factory interface. We get the factory pointer based on the type. And here we have either on the client, we iterate over the client components or the server components, but this thing is actually also a function pointer currently. I want to get rid of that at some point. So this is not the factory interface, this is the component function list. Just to clarify, asterisk is a pointer in Ziglang, so self is a pointer to self. Yes, yes, absolutely. Yeah. So if we go here, for example, we have create. That's just a function pointer. That's a stupid example because that thing doesn't really do anything. Let's go to, I don't know, elevator car. Use the self pointer all over the place. And yeah, you can put together V tables yourself. It's not a problem. You can put together V tables yourself in Odin, and I assume also in C3, but you probably don't really need to do it in C3 because it has support for interfaces. But yeah, here's a V table. I probably have a few of these actually. Yeah, you can see we have a few of them. Player controller is another one. Yeah. So player controller interface, and then we have a player controller somewhere. Don't we? Yeah, here's the player controller type for means. Yeah, this is actually what I wanted. The stupid thing with with these interfaces here is that well, there are a few stupid things. They're clearly not like Zig doesn't really want you to work like this. This mostly comes from the fact that my game engine is somewhat object oriented. You have to have stupid calls like, you know, you have self.vtable dot and then the function that you want to update, and then you pass it self, so you have like self 2 times here. I even have a comment here. Note that we have to supply self as the first parameter here manually. It doesn't understand that. Oh, okay, yeah. You're calling a function here. It just knows that no, this is a function pointer. Like this specifically, that is a function pointer in Zig. So this, and then when you make these things, if you want to. How should I explain this? Like if you have an update function that looks like this, and you want to bind that to something, ideally you'd like to do something like, you know, let's come up with some syntax here. something like this, void, and then you put the code in here, right? This is what you would like to do essentially. To the update function pointer, you assign a function that does this, right, and returns void. This is what you would like to do. Well, you can't do that because there are no I don't remember the exact terms here. It's something about like functions not being like R values or something. I don't exactly remember, but the syntax doesn't work. So what you what you have to do here is define an anonymous struct, which begins here and ends here, and it can have a function. This can be called anything, any old function. Doesn't matter, the name doesn't matter. But you define an anonymous struct that has a function, and then you immediately use that function. And this entire thing you assign to update. I typically call this wrap call, just so that I know that, okay, yeah, it's just wrapped in a struct. Like that. I think those are the two like annoyances for me with like doing manual interfaces in Zig. But the nice thing is that you can make a function that I typically call make, which takes the actual type that you want to have the interface point to, and then a pointer to that. And then you wrap all of this ugliness inside one of these functions, and then where you actually use this interface, you don't have to deal with this at all. It can just work absolutely fine. So here, for example, we have client player controller, and we could have more of these guys. And somewhere here we probably call the make function. Make. Yeah, here we go. Well, this is actually we get the type here from outside this function, but you get the point. Any type that has those well, any combination of those three functions that the interface has, you can create an interface by using this make function here. You just give it the T and then the controller pointer here in this case. So yeah, it's a little, yeah. I basically only use this here on the tech level. I don't do this kind of stuff on the game side, right? On the game side, it's all very sort of like basic stuff. You have a component, you have some functions. You do things in those functions to that data. But on the tech side, sort of like where the C++ code meets the Zig code, you have to do a little bit of magic every now and then. Good news, no more manual interfaces in C. Yeah, that's or C3. That is one of the things that I saw today earlier. I was like, hey, yeah. This is turning out pretty nicely. Where was it? It was bunched together with the any, wasn't it? Yeah, interface is an any type. Yeah. Yeah, so I saw that it has interfaces here. It looks nice. It's a bit weird how to add methods to them, but the plus side, I think, is interfaces work with macros. Yeah. Yeah, macros is another thing that I haven't actually looked into them a whole lot yet. Okay, this was a lot of yapping. Let's write some C, shall we? Or C3. Let's actually get this thing installed. I haven't even installed this, so let's download. Installing on Windows. Download the C3 compiler or the debug build. Let's just get the C3 compiler. And as I understand it, there is also some kind of LSB. Which I really hope there is, because I'm kind of hopeless without LSBs. My memory is not what it used to be, is what I would say if it ever was good. Alright, C3, and then inside of C3 we have the stuff. So let's take this C3 folder and put it on the C drive here. and then put it in the path. Path is right there. C3. Yeah, you can see I just installed Odin today earlier on this machine, so I have both of them now. Both of them are new to me. Let's shut all of these down because we made the mistake earlier of not shutting down all of the not shutting down all of the windows, and apparently Visual Studio Code only like refreshes its environment variables when you do that. So C3C, yes. Now we have this thing here. Rightio. Looks like it's working. So let's try to find C3. C3 language support. Yeah, this looks like the one, right? Last released 1 month ago. Published 1 year ago. It does kind of look like it is the official one though, right? Yeah, C3 Lang VS Code C3. Let's go with this one. Funny you should mention that C3 on Linux is great, but I just had an LSP error in Z. I know Odin works fine. I'm no stranger to LSP errors. Zig's LSP is famously kind of unstable and wonky, and it was it was broken on Windows for like 2 months in the fall. Like I have a love-hate relationship with ZLS. I would be completely clueless without it, but also it kind of breaks. I'm sorry to say, it needs to get better. And I don't really have any right to complain because I haven't contributed anything to it. But yeah, it's kind of flaky. It's also not a simple language to parse. We spoke about this earlier in the stream, that Zig, because of the compile time code generation or the compile time code execution, it's a pretty hairy language to parse actually, because you kind of like need an entire Zig compiler in it to like reason about it. So I don't envy those guys, you know, their work. Odin's LSP seems to be kind of solid. I agree. Odin's LSP seems to be very solid. C3 LSP is pretty bare bones. Oh, okay. Well, we'll see. We'll see what happens. Last time I tried it, go to definition barely worked. Oh. Well, let's see what we have. I'm gonna click install here, and we can. Yeah. This dialogue is such a joke, right? Do you trust the publisher C3? Well, I didn't know they existed before today. Well, I guess I do. Like if you stop to think about it a little more than like the half a second everyone realizes that it's there and presses trust. If you stop to think about it a little more than that, you realize that like we really shouldn't be trusting anything. But I guess I do. I guess I trust them. All right. 1 second. I have a coffee situation going on here. All right. So how do we do this? How do we do this thing? If we type C3C, we get some stuff here. We should be able to initialize a project here the same way we do in Odin. And I think I saw something about a template. Yeah, init new project. Here we go. This search is really good, by the way. I'm impressed by it. You just find all kinds of things using it. So we want a dynamic library. We want a DLL essentially, or a WebAssembly. Like this thing supports WASM, right? WASM. How do I use WASM? You can try this. Compile blah blah blah. WASM 32. Yeah, WASM 32 is what I use actually. That's one of the things. We were speaking about WASM earlier. I actually, like, my mods are 32-bit, and even though the game is 64-bit, so that makes it kind of interesting, to say the least, to do some of the pointer shenanigans there. But it's all good. Okay, so C3C init, and then project name, and then we use template dynamic lib. Hey Xluxy, welcome back. It's been a while, and it's all my fault. Okay, let's go into the same place. We have the Odin stuff. Odin mod. No, that's not it. That's the mod folder. It's here. Here's where we have it. So let's create a folder here called C3. We go into that. And we go to that folder, and then we create, what's it called, init. Initialize new library structure. I don't think this is what we want. I think we want the init one, and then with the correct template. It's my fault because I haven't streamed in a while. That's what I meant. Yeah. Yeah, I haven't streamed in a while. I've been working on the game though, basically all of January, so I forgive myself. but yeah, I haven't streamed in a while. I haven't streamed all this year, believe it or not. It's already February, and I haven't. This is the first stream of the year. It's horrible. I need to be better. Yeah, this init library or init lib, I think it has something to do with these like C3L things. C3L library search paths. And if we have any C3 gurus in the chat, they can correct me here. But I think we want this init one, like this documentation states. Like this. And then we do the template one. Let's try that and see what happens. So, so the other one was called Odin mod. Let's call this C3 mod. So C3C init C3 mod dash template dynamic library. Bloom. C3 mod. And we have some stuff here. Okay, cool. So let's do code dot. And again, do you trust the authors of this folder? Blah, blah, blah. Yeah. I do. Of course I do. Yeah, this is a dynamic library. So what do we have? Oh, we have some git keep files here. I don't need any of that. I'm not going to put this in git. Yeah. This bad boy is going into SVN. So all of the git stuff. Bye. We don't need a license file, and we don't need a readme. I bet we need this project JSON thingy though. Probably don't even need any of these folders, do we? I don't think we do. Let's delete all of these things that we don't need. Library, I don't know if we need that. Docs we don't need. Test we probably don't need. Let's keep it simple for now. Source we do need when we actually have our... Oh, okay. You can enable C3 LSP for a better editing experience. Yes, please. Alright, is it on? Hey! Hey, look at that. Cool. Print N. Print N. It's not print LN. Print N values is done. Alright, so it's like new line. It's basically the same as print ln. Okay, cool. Well, LSP seems good so far. I just want to confess that the only reason I use Ada and Odin a bit more than C3 is because the LSP of C3 as established is a work in progress. I doubt it would have... I doubt I would have spent months in Ada if the LSP was bad. Yeah, okay. That's a bit concerning, but let's not judge it before we've actually... Or I'm not gonna judge it before I've actually tried it out, right? What are you working on, though? I've been doing level design. I've been doing nothing but level design for basically all of January. If you look at my... Oh, I'm not even signed in to GitHub. Look at that. Yeah, I haven't... I haven't really been using this machine at all. Partly because I haven't streamed, of course. Let's see. Yeah, you can see here. You can see here a January-sized hole in my commits. Because I've been doing nothing but level design, so I didn't like commit any code for like a month, basically. Yeah, I think I posted like one image of one of the new levels in the Discord. Yeah, they're coming together. They're kind of ambitious, let's just say. And I need to get further with them, because I've been showing off the same 2 or 3 levels for like a couple of years now, and I need to get further with the campaign of the game. I'm looking into other languages just as a palate cleanser. So the plan is that I will be getting back into streaming and doing a whole bunch of like various game devy things, both like level design, asset creation, all of that stuff, and also programming. Yeah, this is just a palate cleanser. That's why this stream is called Just for Fun. I have a little bit of a thing that I'm planning to do with this if I get Odin and C3 and perhaps even some other, as of yet today, untalked about languages working as mods. I hinted at the beginning of the stream that I'm planning to do some fun things that are kind of related to Traction Point, but it's like it's a little bit under the wraps still. Are you a full-time indie game developer? Do you also have a full-time, part-time software engineering, I guess that is, job? I'm not a full-time indie, no. I do work in the games industry though. And that's another reason why I haven't been streaming in a while, because I work part-time at a large company, a large game studio, and I have been spending my past few weeks there. So I do games all the time. I'm a game developer full time, but I don't do this indie stuff full time. I don't have the money to do it. Blah blah. Maybe try the Helix or Codium. Yeah, it looks like C3 LSP works for you. Yeah, I don't know. We'll figure it out. I mean, this looks good. And if we do like print, we get nice print. Any value to stood out. And this looks nice. I haven't really been doing anything particularly interesting yet, but we'll see. This thing is not exported though, and this is the main function. So I'm a bit confused. Why did it give me a main function here in a library? This is a dynamic library. But let's figure it out. So, how do we build this thing? Build project. Build commands, I would guess. Compile individual files, that's probably not it. Test build. C3C build. Build the project in the current path. Okay. Let's try it out. Give me a terminal here, please. I can make this a bit larger again for you guys. So C3C build. Hey, we got a DLL. Isn't that cool? Now this DLL here, we're gonna need those. Let's do developer command prompt VS 2022 again. I'm just gonna copy that guy. So here's our DLL in the build folder. And if we do dump bin exports C3 mod DLL, we get an atomic compare exchange symbol is the only one that is exported. So we actually don't have any of the exports. I don't know why it gives me a main function. That doesn't really seem very useful. But if we do something like fn int add numbers a b and then we do a plus b. Now let's do another one while we're at it. Sub numbers, something like that. We can probably even take that away. Let's comment that out. I shouldn't need any of that stuff. Right, that built at least. Yeah, we don't have any exports, but I think export. Use a function global constant blah blah blah. There's an export. Yeah. So let's put this here and there. Huh? Expect at the start of a global declaration. Oh, they go after the thing, right? They go here. I think. Shout at me in the external export. Yeah. Shout at me in the chat if I do something stupid. Yeah, that worked. Oh. Yeah, they get some name mangling here. Can we do this? I think I saw something like that. Oh, we need to build it, of course. Yeah, all right. Cool. So, this is how we can start building up our interface, right? Let's look at the Odin one. So we have main Odin. We already have some functions here that we need to actually expose or export. And just to show you that this is actually the same thing. Whoop. Nope. No. Just to show you that this is actually the same thing in Zig. This is the actual game main file, so it's a little larger than a mod. But the idea is the same. We have version number, init library, dinit library, register component types, export function, and here we have version number, init library, dinit library, register component types. So let's just start with these guys, and then we're gonna get to the really juicy stuff with the code generation a bit later. So I'm just gonna comment those out, put them down down there. And let's convert this. Oh no, that's not good. This would be a. Is this uint? I don't know the type names here in this version, in this C. Oh, that needs to be an at, and then it needs to actually get this probably. Yeah. Let's take that away, and then we can comment out these guys. What are the basic types here? Uint. Yep. Uint ulong. Yeah, I can say I'm a fan of this old school naming convention here. It's like what's a short, what's a long? Like no one knows unless you have a name. Just call them like U16, U32. Oh well, we'll go with it, I guess. Get version number. What is this complaining about? Missing return statement. See, the LSP seems to work fine here for me right now, at least. That's nice. How do you do constants? Is it just here we go, integer constants. Okay. Can I just do like we have some version numbers there that we need to actually we need to actually like hard code here, like I've done in in Odin. These will come from a better place, shall we say, later on. But can I do something like this? Can I do const uint basis API version number equals 2? Is that okay? No, yes, might be. And then we have means lib. So basis is the game engine SDK. Means lib is means, first of all, is traction point. That's the project code name for the project before it had a name. And means lib is the traction point library. So that is like a thing that well, doesn't exist here in the C3 code yet. But we're gonna have to actually do a little bit of that if we want to actually be able to create mods with this later on. Does a typical classical C ternary operation work here? Can I do if version number type equals 0, then basis API, otherwise means lib API? Does that work? Like another thing that makes me kind of interested in C3 is that like it is supposed to be just an evolution of C, and of course I do know C and C++ and C# and C-like languages, so it should be kind of nice for me to like just write this stuff. Like with with Odin, it's like super, it looks just weird to me, like return this if that is that, else this. Is like, okay, well, I'm sure this makes sense, but like to me it just looks backward. So I have to look up these things, at least, you know, so far. I have to look them up, yeah, in Odin, while in C3 I'm assuming I will be able to just like do a whole bunch of things directly. That makes sense. Okay, so fn, this would be void, and I think C3 wants to have us put the curly braces on the next line. I think that oh, not export, but init library, and we don't have anything like that, so let's just comment it out. Right, Right. Void. Comment that out as well. There's also void. And this will be interesting because we actually have a callback here. We're gonna have to do something about this guy immediately. So yeah, that can go away. Can I comment that? That doesn't work. Can I do this? Yeah. Look at that. Oh. That's not good. We need to give it a distinct name here. There we go. Okay. Alright, so far so good. Liking what I'm seeing. Let's keep those there because I'm not gonna remember how to do an import if I don't have it there as an example. Well, I can find it from any piece of documentation, I bet. Something like this. Move these into their proper places. I think I saw something like def myfunc fn void int float being used for S3. I assume you mean C3. Yes, thank you. That's very kind of you. I saw it too in a YouTube video, and then I saw a different different syntax here in the documentation. So I think they have actually changed it. But yes, thank you. That would have been very helpful if I hadn't seen that, because I think it was actually called def previously, and I think it is called alias now, because I was kind of like following along on the documentation during my lunch break today when I took a look at this. So let's search for function pointers. Function pointer types, yeah, this. And the interesting thing is that function pointers are always used through an alias. There should be an N there. So alias callback, and you are quite right that like previously it seems like this didn't used to be alias, this thing, but instead def. So it seems like they have changed that, but yeah, it used to be def in the video that I saw. Another thing that we probably want to look into now is the package situation. So, well, it's called packages in Odin. Here they are called modules, and the actual like mod code would be, it's Odin mod here and it's C3 mod here, but I want the code that will like eventually be moved into like the game engine side thing to be in the basis module or package. So how do we do that? Maybe we'll just do like a new folder, call that basis. Can I do that? And then I have like the main ones. Let's see. Yeah, bindings. I think is the here is where I have done this forward declaration or not forward declaration, but like type def for this thing. And then we have some common function points. I don't really use these aliases, but we have some code that actually use it. So I think we're gonna have to do the same thing here. We can actually see the original SIG stuff. Let's bring all of this over. Let's make a bindings. Bindings.c3. Right, something like that. And so let's do one of these at a time. And it should look something like this. Right, alias. So this can just be alias. So we're not doing them one at a time, we're doing a whole bunch at a time. And then fn void, I think it's like all of those at least. That's just fn void. That should be an equals. Something like that, right? And then we need a semicolon after that. Do we actually need to like give it a name here? I'm hoping we don't. Does this value need to be here? Because I don't really have a... Only decorations are allowed at file scope. Got expression statement. What? Really? The alias name needs to be in Pascal case. Really? So that doesn't build. Syntax error. Ah. Let's try just one. Let's try just one at a time. Whoop. Actually, let's not try even a single one. Let's try this one. Like, first of all, I think we have multiple issues here. Only declarations are allowed at file scope. I'm still in the Odin file. Yes. Good morning to you guys as well. Yeah, I'm just checking if you're awake. You don't believe me, I'm sure. Yeah, this needs to have a module statement or whatever declaration up here. Yeah, that's embarrassing. Maybe don't try to write C3 to your module to your Odin file. Okay, now it works. And then someone said something about the case not being okay. It does kind of look like it is though. Yeah. Only typed parameters are allowed for so it. Yeah, that needs to be like an integer, and that needs to be, is it a float? Yeah, okay. There we go. Porting C3 inside Odin is meta now. Yeah. Yeah. Yeah, I was just seeing if you guys are still there, or if you're watching Netflix and just listening to me. You passed the test, so we'll keep going for a bit. Okay, let's see. Yeah, I can't do like a mass replacement of this because Odin, of course, has the return value at the back end of this. Int pointer 64. Right. Okay. So alias FP wouldn't work. Ah, right. Okay. So yeah. Okay. So this wouldn't work. Is what you're saying? Yeah. Okay. This looks like you're declaring a function type. Such an alias must have a valid type name, like callback. Yeah, okay. I have mixed feelings about that, but that might be okay. Might be okay. Yeah, yeah. All right. So, I briefly mentioned previously that Traction Point is a 64-bit game, but WebAssembly, the WebAssembly target that we support is WASM32, at least for the time being. We might move to WASM64 at some point. But because we need to handle 64-bit pointers in WASM32, I'm very explicit about some of these pointer lengths here. So we have an int pointer, which is usize. This is essentially the same as uint pointer t in C++. So it's 32-bit or 64-bit, depending on the pointer size. And then we have these explicit pointers, which is like u64. CPP pointer is also, this is always a u64. So this would be like an int pointer to something in Zig. This would be an int pointer to something in C++. And then we have a WASM function pointer, which I guess we can bring that over. They are 32-bit indices, actually. Is there any practical difference between native versus browser WASM32 versus WASM64 targets? It depends a little bit on what you want to do. I compile, as of about 3 or 4 months ago, I compile my my mods to something called WASM32 freestanding. I don't have it here in the recents. Let's see if we can find one of the mod means data. Yeah, my mods are in SVN. If you're wondering why we're in SVN, I kind of consider it like data. My code is in Git, but all of the stuff we'll be doing today actually currently lives in SVN. Flying Scout code. Yeah, here we have the workspace that I was looking for. So we're gonna have a look here. Build utils. Let's make that a bit larger. Bring that off to the side. Where's that? Here we go. Right. So we're building this as freestanding, as opposed to WASI. So WASI is stands for WebAssembly System Interface, and it is like a standard for if you're building a piece of code. If you're building a program that is compiled to WebAssembly and you want to run it locally on a machine, let's say it's like a command line tool of some kind, like you're, I don't know, validating JSON or whatever, and you need to be able to validate JSON, you need to be able to read files. So you give it like a JSON, the path to the JSON file, and then it prints, you know, OK or error or whatever. You can build that as a WebAssembly module, and then you can run it. And if you're using WASI, it will provide you with the ability to read files, right? Because WebAssembly is sandboxed. That's like the whole idea why I'm using it, is that because it is sandboxed, mods can't just go and open files, for example, to make them essentially like more secure, prevent the whole Minecraft situation with like lots of mods that have like spyware and whatnot. If you're building it as freestanding, so another of these would be WASI, for example. But if you're building them as freestanding, that means that they don't really have any access to the outside world at all, right? But the standard way of building WebAssembly modules for things like command line utilities or whatever is to use WASI, because then they can actually like communicate with things, right? And I think WASI can also be used from the browser, though I haven't really used it ever for anything, but that's my understanding anyway. But yeah, I can do freestanding. The reason I can do freestanding is because I inject all of the functionality into the mod. I explicitly expose the ability to read files to the mod, right? So here, for example, well, I actually don't do it here, but I could, if I wanted to. I could do basis, resources, resource manager, and acquire resource, and you could go like, I want a mesh resource pointer out of this, and its path is at data meshes tree.bin mesh. That would give you a this will now give you a pointer to a data file that you can read. Or if you don't want the mesh resource pointer, you can just go raw data file pointer, and that will give you a raw data file pointer. File and get raw data gives you a slice of UH, but I do all of this explicitly through my game engine, so that is why I can actually bind this thing to freestanding. So that's like a long-winded way of answering your question. That like, yes, there are typically differences. It kind of depends what you want to do with your WASM module. Yeah, you have WASM 64 here, at least on the Zig side these days. Not all runtimes support it. Just like a whole bunch of different ones here. Not all WASM runtimes support it. I use WASM 32 still at this point. I will probably be moving to WASM 64 at some point. That's a neato sandboxing idea. Yeah, you're welcome. It's not. I didn't come up with it. I assure you. Other people have done the same. But yeah, absolutely. Microsoft Flight Simulator actually does something kind of interesting. In that they use something called, what the hell was it? I don't remember the name of the library anymore. You can actually look it up, but what they do is they have their mod makers compile their source code to WASM to make it sandboxed, and then they actually extract that WASM and compile it back out into a into a DLL, probably for like performance reasons, I would assume. So yeah, they kind of do the sandboxing, but then they like essentially like change their mind at the end. There was a, what the hell was the name of the thing? It'll come to me in a bit. Let's keep going. I spoke about these int pointer thingies. We're gonna want to actually set these up here in the basis main file. So let's create a basis main file and call this basis.c3, and we do module basis, and then we have these things up. Did I not copy them? So this would be alias should look almost like this, right? Not U size though. What was the thing? What was the thing? U pointer, right? U pointer looks looks promising. On 64-bit machines... oh, they have signed pointers as well. Signed pointers. What in the world? Is that like a... Is that a relative pointer then? But yeah, that is... Anyway, that is what we want. And then this would be u long. And that's u long. And that would be just u int. Right. Like so. Like what is it? What do you need a negative pointer value for? That sounds kind of funky. I32. That's just an int, isn't it? Yeah. That's just an int. Let's build this. Yep. Coolio. Yeah, I don't think I really need all of this. This is something that I did back when I was really starting out with porting to Zig. And so we have all of these weird kind of aliases here. I bet I don't use all of these. I do use some of them though. So I'm just gonna put that in here right now. Oh, that's an I. Yeah, that's an int actually. That's an integer, and this is a boolean. Like so. This would be a float. Now we have 2 ints. Like so. There we go. Yeah, I will say that the LSP is a little slow, but that's okay. It just like it is a little confusing sometimes because I'm like, didn't I actually fix that? And then it goes away just when I thought I had something bad there. What is this? Right, that's actually a... Yeah, that we have 2 now. That float needs to go away. So that's int pointer, u. That would be an u int. Maybe I can do like a replacement here for these things. Oh. Yeah. Okay, so here's a question for you C3 people. Here's a question for you C3 people. In Zig we have something called extern struct, right? I'm gonna go and have a look here at the language reference to get the terms correct. So an extern struct is in-memory layout matching the C ABI for the target. What would the thing be? What would the C ABI matching struct type be in C3? Is it just a struct? Is that just what they want you to use? I assume there's some funkiness going on with this struct since they can adhere to like to interfaces, and they can have methods, and they can have all kinds of things. But is the actual like data layout compatible with C, or do you need to mark them as being compatible with C? ABI. C interoperability. Okay, here we go. Let's see. Xluxy thinks it's compatible. With Odin, I think it is also compatible. At least that's the impression I got from the Odin documentation. So let's go with that, and I'm gonna have to change it later. Like in Zig, I have these interop types for a whole bunch of different things, and we are actually going to have to port these over to C3 as well. I think it's exports. It doesn't say it applies to struct. Okay. Oh, that's interesting. So, okay. Yeah, what actually happens? What actually happens? Let's take some of these funkier ones away for now. Right, like if I do like I don't have any structs here. What was the thing? Struct types. It's just struct person. Okay. So if I do struct test thing int I float f. Right, now I build it, and of course nothing happens here now, right? Still have the same thing. What if I now do an export here, just like that? Then I build it. What happens here? Yeah, I don't export anything because like it would only be the functions, but let's assume that is the case. '25th needs to go. Thank you for your time. Oh, you actually had some questions. Let me see if I can quickly answer it. Speaking of your Zig port, you mentioned your engine kind of object oriented. Some EZS or something else as well. It doesn't use an EZS, though I have used EZSs with it. There's a fairly old at this point video on the channel where I use an EZS with it. Like you can just, if you want to, you can just have a single game object containing the entire game, and then within that game object you have an EZS. And then you drive, you know, the render and everything, physics from that. That's completely fine. And so what I did was, I actually answered this already in the stream earlier. I don't remember who asked it, but in the video I used this entity ECS with basis, and I did some slightly fancier. I didn't have everything in the same game object. I did some slightly fancier things there, but yeah, I've used it, and in my other job I work with like an ECS based engine on a daily basis, so I'm quite familiar with it. But no, the basis engine isn't really an ECS based thing, or the model that I'm using now isn't really an ECS based thing. But like it could be, or it could have two. You know, like Unity has built mono behaviors and ECSs, dots, whatever. Traction Point doesn't really use an ECS though. That's like leave it at that. I think that's probably the best thing to say. But yes, go do your own work. That's more important than seeing me ramble here. Thanks for your help today, and good luck with your own stuff. And see you later, maybe. Coolio. We're gonna keep going though. I'm gonna drink some water. And we are going to create a file called interrupt types. That's the physics interrupt types. We're gonna need to, maybe there are in bindings actually. Yeah, here we have all of the interrupt types. So we actually encountered this interrupt vec3 already, which is an extern struct. We're gonna take all of these guys and we're gonna take all of them, I think. We're gonna encounter them at least when we start doing the code generation for the API. We're gonna encounter these guys. So I think it makes sense to do that. Let's bring those over, put them in bases, or in bindings. Sorry, we had we have the header there as well. So let's do them first and then come back to these guys. So this would now be a struct. We can do a replace for all of these things. Struct. Bloops. As far as I can tell, C3 structs are compatible with C, but I only found one person in Discord confirming that. Okay, thanks. Thanks for checking. Are we like yay or nay on having the export here after the struct name? uSize was it U pointer? Yeah. And that would be CPP. Or no, is it uint pointer? Uint. No? I forget. No, it's U pointer. Okay. Nope. Don't wanna. Let's go with nay. Okay. Thanks. Thanks for checking it up. That's supposed to be, yeah, we don't really. That's also uSize, is it? Yeah, so we have CPP and we have Zig. Yeah, that's just 2 pointers, exactly. That's just 2 pointers, so it will be Zig, it will be like that. Confused here. And hopefully this thing, yeah, now it goes away and it doesn't want that. Yeah, so we can also replace all of those with just a curly bracket. And then we can do probably that. Replace that with nothing. I could probably get the new line there as well if I really put my back into it, but apparently I didn't, so let's go with this. Right, and then we have a whole bunch of you know, floats that need to be covered. So float. I don't think we have any like initialization here in place, right? That's not a thing. That's not a thing in C3. We don't initialize them. Compile-time properties. Did I not have struct types? It's a sub. Okay, this is where we were actually. Yeah. Yeah. So we don't initialize them to anything there. This seems to be like the way you do it. You just like very, very sort of by hand. Initializing structs. Okay, here we go. Okay. Well, even if you can initialize them somehow, we don't want to do it for these interrupt types because we're not going to be using these like directly. Oh, I'm getting a phone call. 1 second. Alright, sorry about that. We are back. I think we can probably do like this basically. Replace just these with semicolons for all of these. And yes, you can see I do like these math types. Math types are very much like just POD types with a bunch of floats. These could actually kind of be maybe folded into the same type. Vectors could be just 4-dimensional vectors, same with quaternions, and then these could just be like a letter must precede any digit, so underscore counts as a digit here, does it? That's strange. So we actually get a oh, so many. Yeah, we get one for every single line. Okay. Let's call them E instead for element. All right. Yeah. Of course, we didn't convert everything, so that's that. Okay. U8. Was that like U char or something? Basic types. iChar. It's just char. Okay. iChar and char. That's gonna be confusing later. But okay. Fine. Then we have int pointer 64. So this is kind of like the game engine's version of the any, because we have a pointer and then we have a type ID. So uint type. That's an integer. Interop vec. Yeah, here's some raycasting things. So you can see we're dealing with some like pretty advanced things here immediately before we even have anything working. And the reason for that, of course, is that like we have this huge API surface that we are immediately binding to. What was that? That was a U size. Yeah. UPTR. I need to try to talk here and do these things at the same time. So uint. So we're doing like physics interop raycast results here before we even have the thing loaded into the game engine. The nice thing about doing it this way is that like I have it done now for 2 other languages, that being Zig and Odin, and once we have this done, it is essentially all done. Then it's just a matter of making a nice API for us to use. So here we have, this is a Zig const pointer to something that lives in C. So that should be kind of easy. It should just be, that was char, or actually const char pointer, right? Something like that, I'm assuming. And this would be uint. So you can see here that the interop string is essentially a slice. It's a pointer and a length. The buffer is basically the same thing as well, except it has a capacity in addition to the length. So very sort of basic things here. There's no magic really in this binding business at all. Interop blues file mapping. Something that we are really not going to be using from any mods ever, but I don't know. Let's just port it over now that we are doing this thing. And then the actual like API is of course generated. So if it changes, we can just regenerate it for all of the languages, which is also kind of nice. That would be int for all of those guys. And here we have a semicolon. And here we have a uint. Same thing for those. I'm almost done with this boring crap. You probably can't use const there. Oh, really? You mean here? Const is only used for declaring constants. Really? So we can't have a const pointer then. In that case, it probably actually doesn't matter. I mean, this is... I mean, I believe you. I have very little... experience with this language. What does it actually do? Yeah, it does. Type name was expected here, so it doesn't let me do that. I can probably just take them away. It doesn't really matter here in these interop types. Yeah. There we go. Oh, and here we have a... Okay, here we have... that is what I want to click. Here we have some SIG syntax still. We have a Z string type in the std.lib that's defined as an inline char. The Z string, I think I actually read this. Isn't the Z string like a zero terminated string? Yeah, null terminated C start string. Inline char. Yeah, the inline is interesting. That's interesting. Yeah, okay. I don't want to use a Z string here though, especially not in this buffer, because this buffer might be nothing but null termination characters. So like this is used for like binary things and such. I'm just gonna leave it at that for now. That's a nice thing about C interop. It's kind of forgiving. It's actually kind of way too forgiving in many cases. Rightio, here we are going to need probably a U short, right? U short, yes. A couple of U shorts even. And then we're gonna need a 64 element array of floats. So I'm gonna have to figure out how to make that arrays. Okay, int 3. So this would just be float 64. Right? Is that what it's supposed to be? Yes. Kind of looks like it is. Yeah. Yeah, and can I just say how much nicer this syntax is compared to the C one, like this thing. Why is it at the end? It's part of the type. Just put it there. I don't know. That just seems much nicer to me. Okay. Coolio. Missed an alternative part. Yeah, as far as I know, that's what the Z comes from there in the name. And let's see. Okay, so that would be... Now we're almost done with this finally, and we can get to to this guy, which is the original thing we wanted to actually get to here. So we can have this callback here, so that we can put it into here. We're almost done with this this detour. Right, this would be a const pointer again. And I'm sure I can't do that here either. So that's interesting. That's something that the code generator will then will have to be aware of as well. And you int, right? Yeah, the go-to is a bit wonky. Now that I, and that seems to, these seem to work. That works. If you go here and you want to go to int pointer, which is found here, that seems a bit wonky. You can't even really do that. Go to definition. Yeah, it doesn't really work. So I think it was 25th who said that the LSP is a bit wonky, and then, yeah, I can see that being the case every now and then. Then again, all of them seem to be wonky, except maybe the Rust Analyzer. Rust Analyzer is rock solid. It's really quite remarkable. And the Odin one seems to be pretty good as well, to be fair. Right, so this should work. This should now build. And again, if I put one of the consts here, it probably doesn't know. Const is a keyword. Can it be used as a parameter name? Well, I'm not trying to use it as a parameter name per se, but that's a little weird for a language that is supposed to be just an evolution of C. You can't have const pointers, but maybe there's a good reason for it. Okay, let's do this one now then. So this would be a function which doesn't return anything, so it's a void, and its parameters are interrupt typed pointer, interrupt string pointer. Yeah, so okay, this is not a pointer. That this whole type is a pointer, so it's PTR, but this is an actual pointer. And here we can maybe actually be a little nicer to our future selves and add the parameter names here. Like, I'm assuming this is fine to do. So that would be uint type name hash. And this would again be an interrupt string. Update sorting key. Int pointer 64, factory interface pointer, and then uint flags. All right. Yeah. Oh, and this needs to be a C calling convention. Function pointer. How does that work? Calling convention. Call conv. Used for function. Sets the calling convention, but maybe ignore if convention is not supported on the target. What are the different ones then? Oh, here we go. Yeah, C decal, I guess, is the one that we want. So does that mean that we actually want to put it here? Is it like that, maybe? They do some weird stuff where you declare parameters as in doc comments, and while we're around, if you try to modify those. Yeah, okay, so I don't know, should this be like a string or something? They had the what were they called? I forgot it already. The concepts, or let's see, contracts. I'm assuming you mean like these things, right? You can have some like requirements. Require, ensure, param. Oh, is this actually exactly what you were talking about? In out, readable, writable, parameter annotation. Yeah, this kind of looks like what we want here. Funny thing is that these are entirely optional according to the C3 spec. Yeah, I would kind of hope so. Yeah. Yeah, that's a bit weird. Only applicable to pointer arguments, that makes sense. In this allows writing to the variable. Aha. Out this allows reading from the variable. Without an annotation, pointers may be both read from and written to without checks. Okay. And it's checked for null. Well, okay. It's good that you can do all of these things, and it's good that the compiler complains if you do something wrong. Not 100% sure I like this syntax here, but it should be noted that the compiler might detect whether the annotation is correct or not. Alright, well. Okay. Yeah. Yeah, the compiler might not check this. Okay, well. Okay. Okay, whatever then. Should this be a string maybe? Or what is the dealio? Yeah, okay, it doesn't complain about it if you have it as a string. One thing that is kind of neat and something that I've done with Odin and Zig as well is that like you can do Notepad++. Here we go. You should update your Notepad++, by the way, if you haven't heard the news. You can do things like this. You can, if you don't really know how something is to be called, you just search for it in the standard library. All right, we can see. Okay, we can find a single one. That's unfortunate. Can find that one. No. Okay, well it's not used there, but yeah, I did find some Odin syntax that I wasn't sure about by just looking in the Odin folder. Anyway, component registration callback. Now we should be able to go here and just use this. Now we are, of course, we're using the basis module here. So now we need to somehow import that. And it doesn't look like that. It probably will look something like this. Maybe that is actually all we need because it's in the source folder. Let's see. Nope. Could not be found. Just spell it right. Component reg callback. Okay. Did you mean the alias module? Please add import basis. Hey, how cool is that? Import basis. Hey, there we go. What a nice error message. Figured out that I had something like that. Helped me out. What a nice compiler. Why did I have it? Have I spelled it component reg callback here, and then it's called something else in Zig then probably. Yeah, it's called a crazy thing in Zig. It's called an absolute crazy thing. Let's go to main. Ah, okay. Yeah, it's a wasm thing. Password registration doesn't use a function pointer, but rather the callback is hard-coded to a specific external function. Would be nice to have it as a void. Parameter type void is not allowed in function with calling convention wasm. What? Z. So we're gonna have to pass a dummy integer. Yeah, this was a whole thing. It's all coming back to me now. But yeah, this is the essentially like the type that we want to use. Okay. Coolio. So now we have the thing. That's Odin. Bye bye Odin. So still have the register component types. That's nice. Cool. If we try to load this now, the game will complain that we can't find it, but we can see what happens. So let's create a folder here. I'm gonna copy that guy out of it and then do C3 mod. C3 mod. C3 mod. C3 test mod. That's all we need to have there, and then we can just put the DLL here, and the game will try to find any DLL that we have, and we also get a PDB. That's nice. That's probably because I keep building it with. I just keep building it with build. I'm not sure if is this like a release or debug version, but I guess it doesn't really matter at this point. Let's just bring them both in here. And it's here. So this is the Flying Scout. We can get rid of that. Yeah, no, we don't want to save. This is the game. What happened? Not loaded. Alright. So it has figured out that we do have a mod called C3 mod. It's not loaded. We need to restart the game to load it. And now, if we do that, all hell will break loose. Could not get address of zig function basis in it. Yeah, again it believes it's a zig function because I've written the C++ side as if everything is a zig function here. So I have to kind of understand what it's saying. But yeah, basis init. I do think that basis init is one of the things that we exposed, though, wasn't it? No, it was init library. Yeah, basis init is a separate thing. Basis init is something that is actually part of basis, not the actual mod. So if we shut everything down here, basically, like so, we can go to the game. And here we have those things that we have actually already done there on the C3 side. So we have init library, and this can create, well, it creates the means app, like the main traction point app here. But then on the game engine side, we have basis init, which is here somewhere. Here's basis init. It's also an exported function. And yeah, this is the kind of stuff that we will have to port over next. You can see here in the library api.odin how I have done it. Here we can see basis init. And here, for example, is where I set up the Odin context that we want to use. And we need to like get a hold of this libcpp pointer thingy that gets passed to us. And here we return the 0. I spoke about this earlier, that like if we want to bind even more middleware that's kind of like semi part of the game engine, we can do it here. But that means that we have to bind even more stuff. So I just return 0 here, like no thanks, I want just the core game engine for now. That's fine. And then we have a whole bunch of exported functions, and almost all of these are not implemented. You can see that it's actually even Zig code that's found here, just commented out Zig code. The only things that are implemented are these component factory things, and of course these are needed to do the Odin component that we looked at. We have a whole bunch of things. So we do need to actually export these guys from the DLL. But then once we've done that, I think all of the rest, well, we have a few more here. The mod controller also needs to be, and none of these need to do anything, but they need to be there so that the game engine can find them. But once we've actually brought all of these functions over, all of the rest will get generated for us. Yeah, so there's a bit of stuff to do still until we can actually run some C3 code in the game. Can't be helped. But we do front load a whole lot of this stuff. I am of course talking about these generated bind functions. This is the stuff that we don't have to write ourselves. I will just have to write that C3 writer, which generates all of this stuff. But oh well. Okay, so library API mod and library API. We're gonna need both of these on C3 side, so let's go with that. Library API C3 and library API mod C3. There is also on the SIG side, there's also a library API app used when building the library as an app, i.e. not as a mod. And then the mod one is used when building the library as a mod. So like the SDK or API or whatever you want to call it is the same for almost all of the surface, whether you're building a mod or the actual app itself, but some of these things are different. So I think how long have I been streaming? I've been streaming for 3.5 hours. Quite a while. I think I'll go a bit longer though still, because it's going pretty well so far. No complete roadblocks yet. So we'll try to do at least this. Let's see if I actually do get to the code generation thing today. It should actually be kind of easy to do, I think, but we'll see. We'll see if we actually get there or not. So right, library API. Let's go with this first. And we need basically everything here. We don't need necessarily these guys. These are kind of like shortenings of the type names. But let's go with all of this. Just bring it over. This is gonna completely freak out the LSP, I'm sure. So module basis and then right, so enums. What is the enum associated values? Okay. Enum state int. So this would be yeah, colon and then u int, I guess. And does it want no semicolons at the end. Oh, is this must be all uppercase. This is kind of Do we like this or not? Native dynamic. Library. Yeah, do we like this or do we not like it? I don't know. Can I have... Yeah, it seems like I can have the trailing comma there after the end. That's at least nice. That is at least nice, and we probably shouldn't have any methods here. None. Yeah, I can probably do all of that, like so. I think I want these to have at least like make them like snake case or whatever. No, that's not really. Is it snake case? Maybe it is snake case. Okay, then we have an interrupt typed pointer, and we can just keep it like that, whatever. And struct initialization. This looked like actually kind of neat. So we can do a dot and then the dot ptr is 0 dot type 0. I'm sure I have something wrong here and that's why it's freaking out, isn't it? Maybe not. Yeah, this is kind of pointless here to have a function that returns it, but let's have it anyway for now at least. I can remove it later if I need to. It doesn't feel like it works. This is called Zig. What did I call it in Odin actually? Yeah, I call it just library type. Get library type. I think that probably works. Doesn't really make any sense to call it Zig library type here. The castings we don't really need to do anything special there because we're not doing the WASM stuff yet. That should be just library type. And then do I need to cast this somehow? This enum? Struct enum. Enum. Enum associated values. Possible to associate each value with one or more static values. It's nice that you can have a string here. Type inference. Enum to and from ordinal. Here we go. You convert an enum to ordinal with dot ordinal. Aha. Oh. So I can do like return. Wait a minute. State from ordinal. Right. So this would be library type from ordinal. Is that how it works? And then that one goes there, and it's actually not called. It's called that one. I think the LSP is kind of freaking out here because it doesn't understand anything that comes after this. So let's just comment that out. Do I get any sort of nice help from it here if I try to write this now? Library type from ordinal. Yeah, I don't actually know how much of that was actually LSP and how much was just it found some stuff here in the code and referenced that, but whatever. Oh, here we have some stuff. What is this? There's no associated values defined for this enum. Perhaps won't see capped enums. Inline associated values. What? String description. String description. Do I need to actually like go like int value or something? Huh. Oh, that's wait a minute. String description. That's not what I want. I want them to be uints. But then this thing doesn't, there's no associated value defined. This is strange. Don't quite understand what it is. Why doesn't it want like a separate? Yeah, okay, I can see that, like, okay, yeah, you can, this enum has, like, integer as its backing value, apparently. And then you can associate it with, you can give it a description, then you can get the description out of it like this, right? I don't want to do that, I just want to, like, specifically assign the values to it. So, if I just take these away, I would assume that it probably gives it those values here. And that would be fine. Here though, it's not fine because we want to use this as a bit field. So that's a bit weird. Like what? But what we can probably do is, I don't know. I need to look into this. But what we can probably do is we can use an uint here as well, and we can go like value, right? Like that. Right, like that, and then we can do probably not that one. Return library type. Probably not that one, but we can do, because that's not the ordinal now. Ah, this is weird. It's weird. Why does it want us to do that? Like, you need to give it a backing data type, and then you can assign some fields to it, and that's neat. That's nice. Okay, cool. But I just want to be very explicit about my values here. What? Maybe it's time to go to the Discord and ask. I'm there as well, so I don't need I don't need anyone else to ask for me. I can ask myself. Like I think this should be allowed, right? Is it actually allowed? Oh, it doesn't complain. An expression was expected. Okay, and it's okay. It's because of that. Yeah. Alright, let's see if we can figure this out on the Discord. So... Let's see if anyone is actually willing to help me with this. Yeah, that's kind of strange. That's the that's the first thing here in this language where I'm like, what? What? Am I not like, I'm just not getting this or what? If we need to make it an associated value, that's probably fine. I need to be able to assign that value, like coming from the ordinal back into the enum value, though, right? So we don't want to go from ordinal. We want to go from, like, you know, if you make it an associated value called value, it would have to be something like from value, and then you give it the value, and something like that. Oh, const c int. Oh, look at this. Look at this. Look at this. Oh, am I just missing a const here? Is that what is that the problem? Oh. Haha. Okay. No? From ordinal. Okay, what? It's not called that, right? It's called... What is it called? It's called from ordinal with... Yeah, okay. I see. It's called that, isn't it? Nope. Constant is only valid with the compile time constant arguments. Maybe... What? Okay, can I... Oh, Jesus. Main counter enums that are not sequential. Yeah, okay, right. You can use a const enum. If you need a const enum to be converted to its assigned value without using a cast, inline can be used. Aha. What? Const inline string. Or you can just assign it. Okay, const behaves like a type def. Will not enforce that every value has been declared beforehand. So, okay, I can just do this then. like, let's see, type, library type is that, so that would be type, and then return type. What is type here? That's a uint, and this thing is a uint. So I'm thinking this should work, but it maybe doesn't. It's not permitted. You may do an explicit cast. Okay. I don't know why this works then. But that seems to work. Okay. maybe that's it. Yeah, so const uint, and then you get the values like this. Okay. That looks okay. Right, then we get to the actual meat of this thing, and we will basically do the bare minimum that we can, which is, well, basis init will do something. This one we will completely leave out. We don't have that anything like that either. Nothing of that. And then all the rest of the functions we will just need basically to have the function there. It can be an empty function. So let me remember how to do this. So export and then the name there, right? That's a uint 32. So we take that away. Uint. Basis init, and then we have interrupt type pointer, and this would be lib, like so. There we go, and this would be a u32 flags. We don't have the asInt stuff here. Basis init flags, yeah, that needs to be like so. That's probably that, but we have it bind goofy. Does that work? Implicitly casting basis in flags to uint is not permitted. You may do... Yeah. Okay, that's basically the same as in like, what is it? Is it C# maybe? Or maybe even C++, I don't remember. Bind timbre. We don't actually want these. I'm gonna comment them out because we don't have any of these pieces of middleware here. So that is how we would want to do it if we were to want to bind all of that. Oh, duplicate symbol, version number. That is exactly true. So I'll just comment those out for now, and we will return 0. That's fine. Right. So we have this. I don't really want to do any of this, but you know, let's at least like turn it into C3 syntax. That would be uint This is probably char pointer. There we go. I'm not gonna do the rest of the function. Let's leave it at that. And yeah, I think this one is actually not even like it was doubly commented out. I think that is because it is actually, it used to be a thing. It's actually not a thing anymore. We don't have a basis D in it. Even here. Oh, we are in the file itself. Yeah, it's commented out here, so it doesn't matter. That one we can leave. Yeah, this is the sort of stuff that you really you want like a good podcast on in the background and then just like zone out while you do this. Let's see, is the LSP just being a little slow again, or is it actually a function name must start with lowercase? Ah. Oh. But may be able to export it with an uppercase, right? Yeah, luckily we can actually export it like that. So let's see if that actually... Yeah, we have it with an uppercase here because we actually want the API should be with a capital P, uppercase P. So luckily you can tweak the name there on the linker level. Fiddle with the name. Well, yeah, I kind of don't really mind that their naming conventions are strict enough to actually be compiler errors. I kind of like, to some extent, kind of appreciate that. Tends to make the code more sort of, well, easier to just reason about when that's a void, right? Yeah, it's a void. Kind of makes the code easier to reason about when it looks the same, right? Int uint. That's a CPP pointer. There's some SIG stuff here still. Float. Right, I'm gonna make the code a bit smaller here so that I can see a bit more of it. You're free to ask me to make it larger again if you feel like you're not catching it properly. So this would just be returned 0. These are among the first things I will actually have to implement because these are the... Oh, that's a WASM one. I think I'm not gonna do anything about that now that I think about it. So I'm gonna do just this one. Just that one. Int pointer 64. Make it a small c there. C, of course, stands for component. component factory calls. Comment that out so that I can see what I need to do then eventually when I do it. Like so. Void small c. Oh, we need to export that. Let's not forget. Lest we forget. And also shouldn't forget that it needs to be exported with a capital one. Rightio. Oh. Careful with my keystrokes here. Yeah, it would be nice to find some way to like do this kind of mass replace some of these things, but they're kind of like they're just specific enough to each and every I'm done with this. Specific enough to each and every function here that like I don't really feel comfortable like mass replacing a whole lot of this stuff. Some of it maybe, not a lot. Void. Yeah, we are truly front loading a whole lot of stuff here. One way to get around this would be to like make it more kind of configurable what the game engine actually expects to find here in this library. Currently it kind of just like expects to find everything. At least everything in the core engine. So it gets cranky if it can't, you know, find the function to create particle systems or something like that. It wants everything all at once. Nothing can be left out. Which makes this initial work here very, very long. That was something probably. That was an int pointer 64 that it wants us to return. Int pointer 64 return 0. Yeah, some of these functions later down the line get a bit longer, but not a whole lot of them actually. Okay, let's see. How can we speed this up? How can we speed this up? The problem is that the return value is here on the back, both in Zig and in Odin. This was significantly easier to do in Odin. this conversion because they both have their return value there at on the right side. But now we need to move it here to the left. But okay, let's think about this. This one we can just do that with. Like so. We don't want that. We want all of those. And then we have export FN. This one we can do just FN. And then space. Yeah, not that one. That one will remain. I think this return value will have to be quite simply hand converted. So that's an integer. And that's an integer. Let's do return values next. Because I think we can actually kind of mass replace those. That's a U32. Right, this is actually just like that. That would be an uint. And same thing here. Oh, that's WASM. Let's not do the WASM at all. Right now, at least. So leave it as it is. There we go. Yeah, that's uint. Okay, good. This is a void function. That's a void. Yeah, we have a whole bunch of void functions now. Okay, good. So then we'll try to come up with ways to like intelligently do this kind of stuff, right? All the way there, and then we'll take these voids away here. Oh, that's also a void, actually. That's an I32, so that would be an integer. Same thing here. And here we have a void. And a void. Right, and I bet this is kind of easily convertible here. So that should be fn void pv underscore. Yep, and then that should be. Actually, we wanna sort of convert this by hand because we wanna push that the next line while we're at it. And yeah, we're gonna have to do the export statements there at the end, of course, but I don't think I can do those, the mass replacement. Oh. Alright, we're nearing the end here with this this round of replacements. Right, let's do fn void space. It's an integer. Alright. And we have wrapped around. All right. This is riveting content for you guys. I'm sure you'll agree. I do know how to make the streams exciting. But yeah, I do realize this is kind of boring most likely. The nice thing is that we are kind of not very far from actually having this done. Right, so now we're gonna have to deal with some of these interesting things that C3 doesn't let us do, like doing the const pointers there again. So let's export that, and now we should have this function finally done. Yeah. So U8, that was char pointer, and then uint JSON length, like so. Oh, that's an int, not an i32, of course. Again, I'm doing the WASM stuff here. I'm just gonna want to actually comment all of this out, not have this at all. We're not doing the WASM side now. Right, this is probably something we can mass replace. So let's try to do it like so. Whoop. Yep. So we're kind of like bringing this down to being almost just adding the export and removing the uppercase initial letter there from the name. But we do have some of these things here that are a little more intricate. So that would be that. This is a uint. Then we have an interrupt buffer pointer. Yep. And we have an interrupt buffer pointer there. Right, and we shouldn't forget that one. Luckily, the game engine tells us if we have missed any of these. We can go in and fix them. Let's get the export down here. Right, and that would be a CPP pointer. I should probably actually generate this as well. Like, the reason I don't currently generate this is that this doesn't really change. Like, when you're making the game, the bindings change every now and then. You expose more stuff, and you just quite simply create more stuff that you want to bind to let's say Zig or C3 or Odin or whatever, and they change. Not necessarily very often, but every now and then it's nice to just be able to regenerate all of that stuff. This stuff, though, doesn't really change all that often, because this is like the main interface to the actual game engine. And that's why I don't generate this stuff currently. But maybe I should. That would make it even easier and faster to add support for new languages. Not that I really plan to do that like a whole lot, but it would make that possible at least. All right, what do we have here? Yeah, that's a U long, right? Let's double check that. The types, basic types and values. U long is a 64-bit value. Yeah, I get that they want to essentially keep the names that they have in C, but I don't like those. I much prefer like U32, U64, I32, U8, and so on, because it is specifically clear on how long something is. But I can live with it. It's not a deal breaker. It's just not really something I would prefer. Yeah, the C-type name's gotta go. Yeah, I agree. Like, what's a U long? What's a U short? I mean, I do know what they are because they are used in all of the C languages. But like, why have those? If you're making a new language in this day and age, like C3, you know, just have the types be explicit, and then have like aliases for those if someone really wants to use them. But I'm sure there are people who prefer their types old-fashioned. So, who am I to say what the right thing is? Yeah, these are similar enough that we can do a whole bunch of mass replacements on them when we get to them, to the propagated value stuff. Luckily. We just have a few of these very bespoke functions before that. Some of these we probably actually never will. We will never end up actually calling, like something like serialized editor state, unless I. Well, it is possible. It's possible that it might get called. This is if you create level editor tools that have code that run in the actual level editor, which you can do. It's completely fine. If you create those in your mod, then these editor state functions will get called. Otherwise, they will never get called. They just need to exist. But yeah, this is an example of something that like could be very handy to be able to like leave that stuff out. Rip. Okay, so now then, the value is different. This stuff, that stuff we can mass replace. So bool local change f64. Oh, really? So that would be a double value time. Yeah, it's actually a double. Probably not very important that it is a double, but it is a double. Int ptr64 pv ptr. So then we have just the value here, which needs to be float. Double int uint. What's this? Short u short long u long. Char. Oh no, that was. What was it? Was it ichar? Yeah, ichar. That's so confusing that it's like the unsigned is the thing that's called char. But okay, is that how it is in C? Isn't the char in C actually signed? Maybe it's unsigned. I don't know. I think that feels weird. It feels wrong, but maybe that's how it is. But this is the problem. Like, you don't know. If it was called I8 and U8, or S8 and U8, if you want to go the Jonathan Blow Chai way, then you'd know that it's, yeah, okay, it's signed and unsigned. No, you don't know. And that's sad. Makes me sad. Let's replace those with that. Then we have the same thing, but we just have them in a different order here for the quaternion. Because why make things simple when you can make them difficult? That's my motto. Okay. And here we have, yeah, that's called PA pointer, not PV, because this is a propagated action, not a propagated value. Okay, excellent. We can mass replace those just a bit. And that was a U32, yeah, so that's a U pointer. No, it's a U int. And here we have a float. Int uint cpp pointer. It's kind of nice to see classical C syntax here in my own project, though I will say that I'm not a huge fan of C++ these days, even though I'm using it basically every day. Not a big fan of it. It's kind of the reason why I went the Zig way when I did. But of course, there's a nice kind of like familiarity with it. That can't be denied. Okay, so that's that. Now we just have the export things left to do. I'm gonna do it like this. I'm gonna take that one, I'm gonna plonk it here into each and every one after them like this, and then we're gonna do one final pass where we copy the name and we change the initial letter in the name, and then we paste it into here, and then we should be done with this stuff. When we're done with this stuff, we should be able to compile this thing and run it, and we should be able to see if we've done everything correctly, that the game engine is cranky, that we don't have the binding functions. The bind functions are the ones that we're going to generate code for. That's what I've done with the other languages, and that's what we're going to do with this one as well. And that is not going to happen today. I'm kind of tempted to do it, but it's getting late enough here that I think I should probably end this stream after we've gotten this thing compiling, and we can see that yeah, it actually does what we expect it to. Oh, we have some wasn't stuff here that I should have again realized that I don't actually want to do anything about right now, but I started doing it, so let's just do them again, or do them too, now that we are at it. But I already at this point want to thank everyone who came to hang out today and help me with this stuff. There's been some really truly excellent advice in the chat today. Probably the stream where I've like needed more help than ever, because I'm doing these things that I've never done before in these languages that I've never used before. And so so it's been really really helpful. So thank you for that. And it's been a pretty productive stream. So to give you an idea of like the next steps, I would write that one C# file which does the code generation for this. And after that, I should essentially be able to run the game with this code loaded and running. So at that point, we can actually start to like properly write code, right? This is sort of like not very interesting and fulfilling to write code like this. Just copy pasting the API really. Okay, what do we have? Interrupt collision data. Right, we probably need that still from some other place. Yeah, okay. Yeah, let's take all of that and we'll put them probably here under these guys. So yeah, here's some stuff that we don't want. Yeah, I'm gonna comment out these guys. I'm gonna do just the one that I really need. For the bindings to work, I actually need all of these, and you can see that they're basically just like POD files. Whoops. So that's completely fine. Interrupt collision data, was it? Or what was that? What was the thing? Interrupt collision data. Yeah, that's the one we need right now. Max point collision. Max collision point count. I think that's 8. Yeah. So let's make a int max collision point count equals 8. And then this needs to be a struct. So CPP shape 0 and nothing else. CPP shape 1. And this is going to be max collision point count. And that's a uint. So there we go, that should be it. Couldn't be found. Let's see. Oh, okay, we need that one as well. Struct. Oh, it's not string, but struct. Yeah. All right. Okay, yeah, it's the same thing there. I'm just gonna take those away because it's just easier to do them all in one go, not have to care. There we go. Missing return statement. I'm sure there is a few of those. So let's do return 0. There as well. Okay, what do we have here then? Oh, okay, that is the exact thing that it is complaining about. Okay, here we go. So now then, now we should see that we have a whole bunch of things exposed from here. All the C factory stuff, propagated value updates, physics stuff, and all of the really core things. So now if we actually run the game and update this DLL here, and then we run the game. We can see, okay, we have the mod on app startup stuff still. Let's do those still, and then after that, we should start seeing those bind functions missing. And when we have that, when we reach that point, that's actually really nice because that is the generated code, like I mentioned. So then we know that, okay, you know, almost all of the boring things that we have to do by hand is actually coming to a close. So module basis like so. So there's something, all of these are void, so that's handy. That means that we can do fn void for those. And we can also comment out all of the bodies. And then we need to do export. Let's see here. So that needs to go there. We can do this in a better way in ptr64, whoop, like so. That's a float. It's also a float and a float. What is that? That's a CPP pointer. There we go. That would be that, and then we have just these, just this stuff. Okay, there we go. Like, I haven't implemented any of this on the Odin side as like either, because I don't use any mod controllers currently. I don't really have support for mod controllers on the Odin side. Eventually, I probably will need to have that. Mod controllers are used almost like as a sort of a main object for the entire lifetime of the mod. So like if you want to do things in the main menu, for example, when we don't have any game loaded or anything like that. We don't have any game object components, but the mod controller is running, so you can create one of those if you need to do things like outside of the actual game. Could not get added to the sig function player controller on message received. I wonder where that thing actually lives. Let's go to maybe the Odin side. Here. And see, where did we actually put that? Oh. It's a library. So where did I just like somehow do that poorly? Oh, I have a wrong name for it here. There we go. So now then, I'm hoping we will get to the bind stuff now. That will mean that this API is finally complete. I'm gonna run this one. Okay, here we go. Bind core. So bind core is, of course, that's the first function that we generate. You can see here. So this is the very top of the file, bind core, and this is now the stuff that like shouldn't really take all that long to actually do. But maybe I'll do that tomorrow. And then perhaps I'll do another stream where we actually do like a little bit of C3 programming and not just API surface coverage. But hey, so far pretty good. I'm liking what I'm seeing here. Those enums had me a little stumped for a while, but we managed to get through that as well. These guys. Kind of liking this language. It's a little opinionated in ways that I wasn't prepared for, but I think I kind of like it. Yeah, gonna have to do some more of this stuff. Anyway, thanks to everyone who came to hang out. We've lost almost everyone, which I don't blame anyone for. But there was a good discussion going on in the first half of the stream. So, and thanks for all the help today. That was really appreciated. If you want to play the game, even though we didn't really play a whole lot of the game today, you can go check out Traction Point on Steam. There's a link in the chat and in the description as well. If you want to play the pre-alphas, you can do that today. Just join the Discord and follow the instructions there. You can get a Steam key for the playtest. And yeah, I guess that's it. Be sure to like, subscribe, do all the YouTube jazz, and I will see you in the next stream. Have a good one. See you later.